Okay, why don't we get started? Welcome everyone for this GMTSAR short course. My name's Dave Sandwell, and we'll go around the room in a minute and introduce everyone. Melissa Weber's over here from UNAVCO, and she's been helping us the last few days in a GMT short course, and she'll be here this morning. And then Scott Baker is here to help out, and also he's the expert on getting access to data and that kind of thing. So I have an agenda here. I think I emailed it to everyone. We'll talk about sort of the objectives of the workshop and so on. But I guess we could just start with the introduction. So we have, let's start with, we have a number of people here. We have GMT developers, and we'll go around the room in a minute and they can introduce themselves, but they're here for the GMT part of the short course. And then next week they have a GMT summit where they're gonna plan their activities over the next year or so, or next decade maybe, I don't know. And then we also have the GMTSAR developers here, some of them, and we're gonna meet on Saturday to talk about development. So let's start with the GMT folks. Paul is back here.
I also do physicists, but I do graphy and magnetic conversion. I'm working with Paul in Hawaii on the Python GMT group.
Hi, I'm Tundu. I'm a postdoc from University of Edinburgh. I'm a technologist, and I'm working on management of spectrum. I'm also on the NGO.
So let's go on to the GMTSAR people. I guess Anders is.
I'm a postdoc working here with David, one of the InSAR developers. I work mostly on InSAR stuff. Well, now I work more lab, and I used to work on GMTSAR, but I was now.
And Scott is around somewhere. We'll meet Scott. He'll tell us about data access and things at UNAVCO. So why don't we just go around the room now and we can all introduce ourselves.
Hi, my name is Jorge Roman. I work at U.S. Air Force in Florida, and I have interest on source discrimination for explosion monitoring and also moment sensor inversion.
I'm Santan Saika from University of Florida at Catholic, and my source. And I used to work in SAR at the same time as but from now on we started and so hopefully something new.
Hi, my name is Mario, and I'm from Peru, and I work in the National Geographic Institute of Peru.
My name is Ignacio. I come from Mexico, and I'm scientist.
I'm JTM. I'm a PhD student at Stony Brook University. I use Scripps data to calculate stress chain in California.
I am Michelle Higgins from Penn State, PhD student. I use geology to calculate securities of
I actually created the movement and
my name is Paul Jiang. I'm from Florida International University. Now a second year PhD student. I'm using SAR and InSAR on the Everglades wetlands, water level monitoring, and also monitor the wetlands.
I'm Matt Burgess. I work here at Scripps, the Center for Coastal Studies in LIDAR. I'm Dustin from Luxembourg. I use algorithmic processing and definition using InSAR.
I'm from North Carolina State University, and I'm interested in using InSAR for frequency of flood mapping. I'm Lauren Ward. I'm a graduate student at the University of Hawaii, studying civilization and
Hi, my name is Kim Jong. I am a PhD student of Oceanography University. My research interests include GIS, typing infrastructure, and land power. I hope I can use the InSAR data and technology in my future.
Sandra. And Scott just walked in. You want to introduce yourself, Scott? And who else is coming? Matt Way. He's another GMTSAR developer. I think he'll be here tomorrow. Is that right? I think he's a day late. So, and then, oh, the online people. And I don't know how to run this online thing. Can I, is it this green tab here?
Actually, the staff center and mute themselves.
Here we go. Okay. These are, okay, can the online people hear us? Do you want to unmute yourself sort of in order and introduce yourself?
Hello?
Oh, I
Hello?
can't hear. Let me, the sound was muted on my computer and I don't know how to unmute it. I tried to turn it up, but it didn't.
Hello, I'm Tanya from Ecuador. I do research with InSAR.
Wait a minute, we're trying to get the sound working. Yeah. Thanks. I did hear some sound. Output.
Oh, it's.
Oh, I see. It was trying to go through the.
Yeah,
Does
and
that
we
work?
had problems.
The HDMI.
Okay, try speaking again. Hello? Singwon, you want to try talking?
Oh, can I speak now? Can you hear me?
Yeah, go ahead.
Okay. Hi, everyone. My name is Yuan. I'm a PhD student in the Australian National University. My project is about investigating the surface deformation of the active tectonic in the eastern Indonesia, like the Banda Sea and the Aranjia region. So I need to use some GPS and InSAR data. That's the reason I came to this workshop. Thank you very much.
Great, welcome. And if you have trouble hearing us, I know you can probably hear me really well, but not people around the room. And I don't know how it works too. We don't have a, we'll try to repeat the question. Oh, I see. Yeah. Yeah, the rattle up here, sorry. So we have Muhammad.
Hello?
Yes.
Hello, David. How are you?
Yes.
I'm Mohammad Reza from Iran, and I'm PhD student of seismology, and I'm working on slip distribution of earthquake by using the joint inversion of InSAR and seismic data.
Great, thanks.
Thank you.
There's someone on the phone line with 181-329. You want to unmute and They have to do the unmuting, right?
Hi.
Is this Misha? No? Who is this?
Yeah. This is me.
Yeah,
Can you hear me?
yes, we can hear you. Please introduce yourself.
This is Massa, and I'm a student of geodesy in USF, University of South Florida, and I'm supposed to work on the slow slope events in Costa Rica, Central America, and I'm really interested in InSAR, and that's it.
Is that with Tim Dixon there?
Pardon?
Do you work with Tim Dixon?
Yeah, exactly.
Great. How about Gökhan?
Can you hear me?
Yes.
Hello to everybody. I am Gökhan from Turkey. I am a PhD student at Istanbul Technical University, and my thesis project will be based on Persian scattering interferometry and to start something about the monitoring engineering stuff. Thank you.
Okay, great. Thanks. Masha? Yeah, we can hear you. Oh, there's a little bit of a feedback. Maybe your microphone. Try it again. Misha.
Hey, David.
Oh, I know. Turn down your sound a little bit. Your speaker.
Did you unmute me?
Yep, we can hear you now perfectly.
Okay, good. It's good.
Okay. We're trying to get Masha.
Yeah.
Oh, is that Masha? Okay, there's another. Oh, I see. You're in two different ways.
Exactly. I'm using my phone because I cannot hear from the computer. So okay. I think you can see Massa. It's my name and also my phone number.
Okay, perfect. I got it.
Yeah.
And did we get? Oops, I might want to turn one of those off. Thanks. Who's left? Oceanography? Oh, yes. We can't hear you. Maybe he's unmuted. I think that's it, right? Have we got everybody? I think so. Okay. As we go through the next couple of days, it's going to be a little hard to work with you guys, but if maybe you should send, I guess there's a chat thing, or there's a chat window? Okay. Oh, yes. So if the instructors can log into Zoom and maybe help people, especially this morning, what we're going to do is just set up our computers to run GMT and GMTSAR. But before doing that, the GMT people set a precedent here that I really like. And they handed out types of stickies, yellow ones, red ones. And you put these on the top of your computer. If you're having trouble, put a red one like that. But if you're not having trouble, you put a yellow one. So I'm going to come around and help you. So yeah, so you're not having trouble. Okay. So is my screen shared? Yes. Okay. Perfect. And they only see the, whoops. Oh, I don't know if I want, are they seeing all the little screens I can mirror this somehow, right? Use slideshow. Whoops. Uh-oh. How do I do this? No.
That part. And then
Oh yeah, did everybody get onto the Wi-Fi? There's a guest thing.
giving me a very small screen.
Yeah. Let's go back to the display thing. I think it reverted to a different.
Uh-huh.
That looks pretty good.
Oh, I don't like that.
Oh yeah.
You know, we were doing with the GMT is just laying it this way.
Really?
Yeah. Just making that larger.
Okay.
And then just page down.
And they can see it.
I'm pretty sure, yeah.
Okay. This short course is going to be sort of a mix of a few lectures. First, I'll do an overview, and then we'll have some things about topo maps and GMT and a little bit of theory. But really, we'd like to, the main objective here is you can walk away with a laptop where you can run your own GMTSAR, gather data, make interferograms, or you might want to do it on a bigger computer, but at least you know how to set it up and do it. So we'll do a little bit about SAR and InSAR, but very little. A little bit about running GMT on your own computer. And then we'll go into the very standard type of InSAR, two-pass InSAR processing, very simple. You'll find there's a lot of sample data sets on our website. I'll show you where that is. Something about selecting data, and this has really gotten a lot easier recently. In the old days, we used to have password protected data sets everywhere, and Scott was involved in that nightmare of setting up all the passwords and the users and all that. But now we have free and open data from Sentinel-1, which is wonderful. So that's gotten easier. Then we have a variety of data sets you can process. The older types of data, ERS and NVSAT, ALOS-1, if you want to look at older tectonic types of processes, and then the newer types of data, Sentinel-1A and B, and ALOS-2. And then finally, more advanced, looking at large stacks of interferograms to do time series. This is a little bit more challenging. It takes a lot of computer time, but it's possible. You just have to set it up and run it for days or weeks or whatever. Okay, so we've been doing this for a number of years, and I'll just flip through some of these GMT-SAR course photos from the past. This is the first one way back in 2011. And then we moved to UNAVCO. UNAVCO started supporting this short course, which is really nice because we don't have to worry about travel. Melissa does all that, and people at UNAVCO and just have to show up. And what's nice is it's actually here at Scripps now. We had it at UNAVCO a couple of years. It's a great place to visit, and We had some nice GMTSAR workshops there. And then we moved to Scripps. People like to come to San Diego, and we've got some less expensive housing up on the main campus, and the weather's good. What? It's cooler. And you see we've locked you into this, it's called the sea cave. So you can't see anything. You can't see the ocean. You think that you're in wherever, in the Denver airport, but really we're right next to the beach. So during breaks and so on, you should walk out to the beach. You know, I use the beach all the time. Hope you brought your swimsuit. I can show you where there's showers if you wanted to go during lunchtime. Head down to the beach. Yao could find you some surfboards, boogie boards. So yeah, at lunchtime or in the evening, there's a lot of time in the evening to do things. So feel free to use the beach. Here's 2016. You can see the short course is growing to sort of an optimal size. Oh, here's one we did. Eric and I went to Beijing and at the Chinese Academy of Sciences and did a workshop, short course there. That was really a lot of fun. Got to see the Great Wall, and they had a really nice university there, brand new. And these students had come from all over China. They were mostly from research labs in different parts of China, and they would go to this Chinese Academy of Sciences and take specialized courses. I think it was just, they would do it for the first year, is that? First year. Different kind of model, but you know, it was really nice. Okay, this one here, this is 2017. Last year, we took a picture with a quadcopter here. We're all down here on the, can you see that mouse? Yeah, okay. We're all down here at the Monk building. And this is where we'll go for dinner this evening. It overlooks the ocean. It's a beautiful spot. There's a zoom in of the crew. Okay. Oh yeah. So Donna Charlevoix wanted us to remind you about this code of conduct. You know, be nice to your neighbor. You know, everyone should. We're going to have people at all different levels of experience. So if you don't understand Unix, it's not a problem. We have people here to help you out, that kind of thing. Okay. So here's an outline of what we're going to do. We'll go over SAR and InSAR theory really, really briefly. And then, but we'll talk more about the processing with GMTSAR. Maybe a little bit of history about where this came from. Rob and I had developed a SAR processor based on a whole variety of codes. And then we realized that we could use GMT to do more than half of the processing because computers got faster and so on. So we decided to adopt GMT as the back end part of the processing, and the front end is all specialized readers for the different types of data. And that's done in C. And then the back end is all done in GMT, and then there's these C shell scripts that sort of glue it all together. And so we're working pretty closely with the GMT people. Paul really helped us out by creating that interface between the two with special file structures that they probably don't like to use, but it's the glue, you know, there's a glue in there. And last few days, GMT has evolved to from GMT5 to modern mode, GMT6, and Paul will show an example. And we learned about this the last couple of days. And both GMT5 and GMT6 work the same way, which is really nice. I was sort of surprised it all worked. I think Eric had to spend a little time with emails back and forth to almost nothing. It almost just worked perfectly. Okay, so that was nice. So you can use either GMT5 or GMT6. You should learn GMT6 because it's much simpler, and we'll see some examples. So we'll set up your computers. That'll be today, and then go through the different types of processing. And then on Friday, we'll have student presentations all Friday morning before lunch or even during lunch. And you'll group into pairs of people and select something that you want to do as basic as just making one interferogram all the way up to trying to do a time series with Sentinel-1 data. So whatever level you feel sort of comfortable at, you can do that. Okay, so today we're going to do setup. I sent all of you some homework assignments, and basically they were here. The first one was just to make sure that you were running Unix. All this stuff runs on Unix, and learning something about ls and cd and just the basic Unix commands. And then what's really important, people always get confused, there's a file called .bashrc or .cshrc or .tcshrc, depending on which shell you decided to use. And within that file, you put something called your path. And hopefully you all sort of learned about your path. So if you install some new software and you type a command, you want that command to be in your path so you don't have to type the whole long string to get to that command. And so that was the point of the first exercise, learning Unix and learning about this .cshrc file. And really, you can use any one of these shells to do processing. The second one was to learn a little bit about GMT, either 5 or 6, and also learn how to gather the topographic information that you'll need to make an interferogram. This is more history. Maybe now we don't even need the topography because the baselines are so short. When the baselines were long in the old days of interferometry, we needed a real good topographic data set. And so this exercise was to go to this website, type in some coordinates, download a digital elevation model, and then use GMT to make a map, and we'll go through those maps in a few minutes. And then the last exercise was to install GMTSAR, and this could be more of a challenge, and we'll spend this morning doing that on everyone's computers, making sure that everyone has GMTSAR installed. Oh, and somebody sent me an email saying that their Unix wasn't up to speed, and I have a couple extra computers if someone wants to borrow a computer. I have a Linux computer over there, a Ubuntu, and back in my lab I have another Mac that's pretty much set up to do InSAR. So if you really have trouble, you can just borrow one of these computers for the next couple of days. But again, the point is that when you leave here, you'll be able to take your own computer, or at least understand how to set up a mainframe computer and do the processing. Okay, so I've already sort of said this. We're going to have presentations on Friday, and there'll be different levels, processing one of the sample data sets, or selecting new SAR data and processing that. That's something, you know, if you're interested in a particular area, this would be a good time to get started. And with Sentinel-1, you can basically select any area in the whole planet and get pretty good data coverage. And then something about batch processing. If you're into batch processing, Sandra actually wrote a document last summer on how to batch process Sentinel data. And I think it's probably hasn't changed much. Maybe we could tune it up this year. But it's sort of a recipe. You do this, you do this, you do this. And it gets sort of complicated, you know, gathering the data and organizing it and so on. Oh yeah, so what I'll talk about right now is just, you know, what is SAR and InSAR, really, really basic, just a few slides. And then Eric's gonna come and talk about some of the applications of SAR and InSAR. Are there any questions about the course? Or I don't see any red stickies yet. That's probably coming soon. Oh, yeah. Oh, the stickies have to go around. Yeah, okay. I like this idea because it used to be we'd ask people to raise their hands, but then they can't type with one hand and they wouldn't make any progress. So you get the sticky there. Okay, so this is really, really basic. Satellite remote sensing. This is my one slide about satellite remote sensing, and it sort of encapsulates everything. First of all, there's three basic things you need to do remote sensing from a satellite. First of all, you have to be able to, this is all done with electromagnetic waves, light waves or microwaves. First of all, you have to get the waves through the atmosphere or the ionosphere. And so there's only certain windows where that's possible. There's a window in the optical part of the spectrum. We look at the sun, we can see the sun, and so this is where our eyes work. And then there are some windows here in the infrared that can be exploited for looking at the thermal properties of the Earth and so on. Then there's this whole region of the spectrum where the atmosphere and ionosphere are pretty opaque. So you really can't look at the Earth there from space. You could do it from aircraft maybe. But then you get out here to the microwave and it gets very transparent. And this is where microwave remote sensing lives. And basically there are two types of sensors in all this. You can talk about active, passive sensors, like you might have a camera out in space and take pictures of the Earth like you get in Google Earth. You could have a thermal infrared camera to look at the temperatures of the surface of the Earth or the emissivity. And then you might have a radiometer to measure the radiation coming from the ocean or something like that. Although this gets messed up by all of our cell phones. You know, all of our cell phones sort of work in this area of here, so it messes up a lot of the passive microwave stuff. And then we have active sensors, and in the optical, you can have a laser sensor. There's one that was just launched recently called ISAT-2, and doing a great job imaging the ice and the ocean and the land, really high resolution. And then you have these things called radar altimeters that measure the topography of the ocean surface. They're just measuring the travel time, like a laser, the travel time of a pulse. So you don't get an image, you just get a profile of the ocean surface. And then here we have synthetic aperture radars, and that's what we'll be talking about here. It's a side-looking radar that images the Earth. Here's the basic idea. You've got a satellite up here about 700 kilometers away from the Earth, and it sends out radar pulses, short pulses, and these, you're looking off to the side, so when the pulse first hits in what's called the near range right here, you start to get a reflection back to the satellite, and then it sweeps across this swath and to the far range, and you create this image across the swath, and that's called the range coordinate. And the other coordinate we call the azimuth coordinate. It's along the satellite track, sort of a historical thing. But when you get the data, it will come in these coordinates, range and azimuth. And later on, we'll want to put everything onto the Earth in lat-long coordinates. So we have to do this transformation from range and azimuth to lat-long. I'm skipping a whole lot of stuff here, but it's sort of the basic idea. Now, because it's an active sensor, with a passive sensor, you look at, you take a picture of the Earth, you're just looking at the amplitude of the reflected radiation, say from the sun or something, just the amplitude, you don't get the phase, you don't get any information about the travel time from the surface of the Earth to the satellite. And so it's the same with SAR. You can get an amplitude image by just looking at the amplitude of the backscatter, but you can also get a phase image. And the way we do it is we take 2 passes before and after some event, difference the phase and make an interferogram, and then interpret that interferogram. So that's the real difference between, so a normal SAR, you look at the backscatter and you can learn all about reflectivity and vegetation and polarimetric stuff, but for InSAR, we just look at the phase. So we'll be mainly interested in looking at the phase in this short course. And in fact, if you look at the amplitude images that come out of GMTSAR, they're actually pretty bad looking. They're low resolution, and because we don't really care much about the amplitude. So if you did look at an amplitude image, this is a little hard to see, but this is a backscatter image of California here. Here's the Salton Sea. Anybody been to the Salton Sea? It's not really the nicest place in the world. It's sort of smelly, and it's drying up. All the runoff from the agricultural fields goes into the Salton Sea and makes it really salty and toxic and awful. But anyways, and we look a lot at the Salton Sea because the San Andreas Fault runs right up the side of the Salton Sea here, and there's a lot of agriculture here. And so we're looking at a backscatter image, and the Salton Sea is dark because the satellite sent out a radar pulse off to the side. The water's pretty flat, as long as it's not windy. Water's pretty flat, and so it reflects back into space. So you don't get much reflectivity back to your radar, back to the sensor. So actually, yeah, I'm going to skip a lot of stuff here, but when you look at a radar image, it's a little different than looking at a optical image, because you're looking off to the side, and what you're seeing is the range to these features. So the mountains look like they're laid over, and things are distorted a little bit. But we're not really going to do much with amplitude images. Just to zoom in, you can see fields and roads and that kind of thing. And later on, when we start doing InSAR, you'll find that these areas where there's a lot of agriculture will be decorrelated because the farmers tilled their field, or something grew between the 2 acquisition times, and it screws up the phase of the interferogram. So, but when you're over here in the mountains, you get beautiful looking interferograms. Or if it's like a city, cities are great. They have pretty stable buildings, lots of reflection, and you get good InSAR. So we're going to talk about the phase. And this is more detail than you want to know, but in the old days, we worried. So what you have to do is, if you want to recover the phase difference between 2 images, 2 satellite overflights, ideally you'd want the reference and repeat satellite tracks to be exactly in the same place, within meters. And if they're exactly in the same place, you can simply difference the phase of those 2 images and get the deformation. So if the ground moved towards the satellite, you'd see some fringes in your interferogram. And the other point here is that you only get one component of deformation. You just get the component of deformation in the line of sight of the satellite path. So the satellite here is flying into the paper, and so you only get one component, whereas something like GPS, you get 3 components. So you always have to remember, it's a one-dimensional thing, where we'll end up getting 2 components because we have ascending and descending tracks. So that's what we're after. But if the baseline is not 0, then you get this extra phase due to the topography of the Earth. And so when we do all the processing, we're going to have to bring a topographic map into the and they use that to map the topography of the Earth. And then since then, there's been a TerraSAR Tandem X mission that's done a really super topography, but you can't get access to the data. You have to buy it.
Could you comment a little bit more on what is the reference baseline?
So you pick one of the two things as the reference. You just pick it. And you say, in fact, when we do stacks of interferograms, we'll pick one, we'll call it the master. So the terminology here is when you make an interferogram, you have a reference and a repeat. Just have two. But when you do a whole stack, you have a master and a bunch of slaves. People don't like that terminology, but there are many slaves, and you align the slaves to the master. So you have to pick one master. That's a very special acquisition. You pick a master, you align all the slaves to the master. So but nowadays with Sentinel, which is really nice, it doesn't really matter which one you pick as the master. And in fact, I'm going off in a different direction, but when you make an interferogram, if the time span is really long, you'll get decorrelation because the grass is growing or the trees are moving or whatever. But with Sentinel, the orbits are so good that you can align all the slaves to the master without even looking at the ground, just with the orbits. So you can do it. You could do it over 2 decades if you wanted to. And they'd be
How much of a temporal baseline on the Sentinel data?
so Sentinel has A and B, and each one has a 12-day repeat. So it's possible to get 6 days, but there's only 6-day coverage in Europe mainly, because it's their satellite. But they do it in Hawaii too, because Hawaii's out in the middle of nowhere. And then there was a big earthquake that Eric might talk a little bit about, but after a big event, then ESA will program it to go every 6 days. But that's pretty nice, 6 days. 6 days from 2 different directions, so it could be every 3 days. Yeah, the world has changed. The world of InSAR has changed from when Rob and I were doing it, and there was no DEM from SRTM, so you had to make a DEM. I guess that's what you were doing. That's what he said you were working on that, and that's really painful because the DEM would be corrupted by the atmosphere and the orbits, and big mess. Now it's easy. We've got good orbits. We've got DEM. Okay, so here's a little bit about conclusions. Atmosphere is very transparent in the microwave. Radars measure in 2 coordinates, range and azimuth, and they measure 2 things, amplitude and phase, and we'll be mainly interested in the phase. And I didn't talk much about this. The amplitude depends on the roughness of the surface and the slope of the surface, whether it's facing the radar or not, and the dielectric constant of the surface. But the phase depends on topography. If you have a non-zero baseline, depends on deformation. That's what we're mostly interested in. It also depends on atmospheric properties, water vapor, all these kinds of things that corrupt our signal. Although there's people that want to look at the atmosphere with this approach, and the ionosphere does the same thing. But in terms of the deformation, there are a whole bunch of processes: volcanoes, earthquakes, groundwater, and so that's what Eric will talk about next. Just some of the applications. But back to this thing about the installation. I already said this, but here's a really basic bash profile. So Paul will be happy that I showed a bash profile instead of a CSH. I don't really see the difference, but you know, he had a bash shirt on the other day, so it's superior, I guess. But you can do things like, if you're always typing ls minus ALH, I don't know what H does. Oh, human readable. Human readable, okay. Yeah, if you're always typing something like that, then you could alias that to LA. This is one I would never do. I don't want the computer to ask me if I want to remove something. I'll take the consequences if I make a mistake. LS minus that, you can do that. But then here's the key. This is from Eric Lindsay. And this thing about the path, when you install some software like MacPorts or Homebrew or something, I think it automatically adds this to your path somehow. Might put it into your .bashrc file or whatever. But when you install GMTSAR or GMT, then you might have to add to your path. So you could append, so the path is sitting at the end here, and you would put in your special path, and you can order these in different ways. You could have it look for your stuff first, and then look later, or you could have it look for the system stuff first. And so it just depends on what this path is. So you should understand what that's doing. And sometimes you have to do this with the libraries. If you're compiling something, you want it to look at that library first, and then look at the other ones later on. Hopefully you don't have to do that. Okay. Any questions? Oh, there's a red one up there. No, I'm just kidding. You don't have a problem yet, right? So Eric is going to talk about some of the applications, because there's a lot of different applications. And did you put that PowerPoint into the Google Drive? Okay. What does the agenda say? Do we take a break now or not? We're sort of ahead of schedule. Okay, I'm going to get the Google Drive up. Oops. So I should probably send everybody this link to this Google Drive, because that's where we'll put all the presentations and other things that you might need. You can do that later this morning. This one here? Oh, it's done. You can make it bigger. Okay.
All right, I might go over time a little bit because I only have like 10 minutes for this session.
No, I thought we're ahead of schedule.
Ahead of schedule? Okay, never mind. So I'll be talking a little bit on some of the applications of synthetic actuator. Excuse me?
Let's go ahead, Paul. Yeah.
So the first session is until 10, but
so we're ahead of schedule.
I'm confused, but anyway. So here is a basic outline. I'll summarize a little bit of what we did last year for the software, and then I'm gonna go into some of the useful things that you can do or work on with InSAR. So mainly related to volcanic hazard, earthquake hazard, some hydrology. Of course, InSAR is not really just limited to those applications. You can also have use InSAR to study glacier flow or urban infrastructure or landslides. I don't think I'm going to talk about the ScanSAR and TOP satellites here. It'll be covered tomorrow, I think. And then we're going to get into some of the cases related to each of these hazards. So some progress from last year. This is mainly a summary of what's being added to the program during the past year. The first thing that we did is adding a program called Cut SLC. So now you can actually manipulate with your size or image you want to process. Well, here the next is we added another script called SAMP SLC. It's basically calling the old script using resamp. Now you can actually easily upsample or downsample your SLC images because sometimes you have a slightly different PRF or slightly different sampling rate, but you still want to want it to work with the program, then you need to use this program. We added a spectrum module, mainly focusing on a simple ionosphere correction. This correction is already built to the patch-to-patch processing. So you're welcome to use it, but it's not very stable yet. You need to be able to know what you are doing to tune the parameters. The other one is called split aperture. This is splitting the SAR beam from a full backward to forward looking to just forward looking and backward looking. Then later on, you can do a multi-aperture interferometry to study the along track deformation. Also, if you are sort of familiar with GMTSAR, you might find that there are tons of P2P script in there in the installation that almost one for each satellite. Now we are developing a universal script for all satellites. So later on, you could just call this one satellite and add the satellite name to let it work for different satellites. Together with that, we also added something to the config file, which is called skip stage. Before, you can only select which stage I want to start from, then it will process all the way to the end. Now you can skip a certain stage that you don't want the program to repeat, like for building topo maps. Also, we added something called the pop config, because you don't want to go back to the folder to load what config file should it be for each satellite. Then you could just easily call this one and add the satellite name. It'll give you a default config file that works with the script. Also, we improved a little bit on the geometry of the satellite. Also, we added a whole frame-wise processing tool for ALOS2 ScanSAR. Added the nearest neighbor interpolation option for phase unwrapping. And also, we're starting to build a benchmarking script to sort of test how much the results has changed when we have an update. So it'll be a more consistent in the later updates. Okay, after this, we're gonna get into the fun part. InSAR is a very useful tool. Here is an example in Theragram over Yellowstone. If you are familiar with there, that's the lake. And that's a H-shaped highway. If you were there, you might want to tour around that circle. So what is being plotted here is after what we call a volcanic intrusion. In other words, there are like magmas that flow into the magma chamber, and then the ground starts to deform. So what really does this interferogram mean? You see a lot of like colorful like fringes, and this data is from NVSAT, which is a C-band data. In other words, from one fringe to another, that means about like 2.5 centimeters. But what does this pattern mean? So the satellite is actually flying along that direction. That's the direction what we call ascending scene. And then it's looking toward its right and downward. So if you look at the color from blue to red, from blue to red, since the numbers are increasing, right? That means if you're counting from blue to red, actually the phase is becoming larger from the ground to the satellite. And what phase means is actually the distance, right? So if you are counting from blue to red and blue to red, and it's increasing this way. So if you are going backward from outside to the inside, it's actually decreasing. So the phase is decreasing in the center here. It means the distance between the ground and the satellite is becoming shorter. In other words, your ground is going up. Also, we have other examples for here, like this is an example from Jolla, an interferogram on the Occomock volcano. It's a shield volcano along the Aleutian chains, like to the southwest of Alaska. Probably Sandra knows more about this earthquake than I do. But this is showing some kind of, I think it's still inflation during the early 2000s. And they found out that this recent interferogram shows a continuation of inflation during 2003 and 2004 at a rate of only about half at 2002 and 2003. So in other words, this interferogram, if you compare this one to a previous one, you'll find that the inflation rate is decreasing. Also related to this, if you think about a volcano, you immediately would think of the big island in Hawaii. So this is an event at Kilauea, which happened along the East Rift, sort of similar to the event from last year. But there's a dike event, it's an intrusion. So if you measure it with 2 GPS stations here, you'll find that the distance between these two is increasing over a certain period of time. But this is only 2 points. If you look at an EOS-2 interferogram, you see that now the color scheme for here means the red is means that ground is moving toward the satellite, and blue or purple means it's going down. So for this situation, you see that this dike is actually opening and uplifting, but over here at the caldera of Kilauea is actually going down. So other than volcanic hazards, you can also use it to study earthquake hazards. So this is the example in 2008 that happened in China, Wenchuan, which is magnitude 7.9, which is a pretty big earthquake that caused a lot of casualties. What is plotted here is the fault trace. And if you get an interferogram over this region, this is how it looks like for the earthquake. It's a thrust event. So that is probably the hanging wall, right? And this is the foot wall. And after you get this interferogram, what you can do is that you can use this interferogram to build a slit model that tries to connect what happened during the earthquake on the fault to your surface deformation. Also relating to earth, also stack like a bunch of interferograms so that you get a nice and smooth interseismic deformation map. This is the work done by Yuri Fialko in 2006 over here in southern San Andreas. From this map, what you can get is sort of, you see that from this end to that end, you have about like 15 millimeter of line of sight deformation across this, like, I don't know, 200 kilometer wide zone. But again, if you know about this region, you know that the slit budget is about like 4 centimeters per year. So why this number is much smaller? It is because the SAR has a loc angle. The 4 centimeter budget is just horizontal. But when you look at from upward and with a specific angle, then it's getting smaller. It's going to getting partially projected to the satellite line of sight. Question?
Question online. Wondering if MAI processing is working with Sentinel data.
Not for now, because Sentinel data. One special thing about Sentinel data is that you have a sweeping feature from backward to forward. In other words, inside your SLC, there's a pretty big ramp which goes beyond your sampling. If you are able to get rid of that ramp, you should be able to do a MAI. But for now, it's not, because the ramp provided by the data, the metadata, I don't think it's very accurate. Yeah, maybe pixel tracking is better than MAI for Sentinel. Also, the azimuth pixel size is much larger than a EuroSAR image. It's like about 13 meters. Most like ScanSAR, ALOS 2 or other satellites, it's like around 4 meters. So I would not recommend to do that, but bye. If you take a profile, this is what you're gonna get. The black dots here are, I think, from the SAR image over here, with all these dots being the GPS measurements being projected to satellite line of sight. And down here is the topography. So it matches pretty well, I think. Okay, some hydrology applications. This is a map by Larry et al. In 2006, which is building an InSAR time series. So later on, we're going to cover what is batch processing. This is the tool that you're going to need to build this InSAR time series to show how the ground is changing over time. All these, it's kind of hard to see, but these black triangles are InSAR acquisitions. Like the vertical axis is the deformation in centimeters. And all those red dots are GPS measurements. So you see it actually matching the GPS and has a pretty strong seasonal variation over here in Los Angeles. If you're purely looking at this average velocity, it may not be that big, but if you look at how much it's changing over time, actually has a pretty big amplitude. And here's another example at Las Vegas related to groundwater pumping, published by Falk Amelon in 1999. So here, each of the fringe is roughly about 10 centimeters. So 2 fringes means like the ground is subsiding like more than 20 centimeters because of the loc angle. Another example at, I think this is Phoenix. This is the interferogram, and if you took a profile along this blue line, this is what it shows, up to like 6 centimeter subsidence over this region. I'm not sure I really understand what this 2 picture means, because this has a freeboard added. Is the water level really going up or going down? Compared. This is in 2001, that's 2003. Oh, maybe that's the reason why it's going down, because of the leakage. Okay. Oh. Next, we're going to go to some of the cases, but maybe before this earthquake, we can show some examples for a more recent one, which is the Ridgecrest earthquakes. How do I make it smaller? So almost right after the earthquake, we start to acquire data from both Sentinel-1 and ALOS-2. So we started to build this website. It will go downward to upward. So this is the interferogram for the 7.1 is a pretty big earthquake, but when you're looking at with the GMTSAR data, it's actually covers only a tiny bit inside the large interferogram. And over here is the unwrapped phase. In other words, there's a technique that you can convert these fringes to a continuous deformation field. The technique is called phase unwrapping. It'll be covered tomorrow, I think. Over here is the MAI result. It doesn't have the ionosphere corrected, so some of the blobs might be reflecting like ionosphere bended beam in this map. Another ALOS2 interferogram more toward the center. But the funny thing is that you see that there's this mass over here. That's actually Central Valley going down. This is like a 1 year or 2 year apart. I think it's a 1 year apart interferogram, and it's going down by, I don't know, 1 or 2 fringes already.
2 years.
2 years probably. And over here, that's a Sentinel-1 interferogram. There's a really cool thing that you can do with GMTSAR is that you can compute this phase gradient map. I can open one of these maps. Might take some time. It's pretty big. Maybe too big to open. No. Yeah. Like 100 megabytes or 100 megabytes.
It's not really pretty bad.
Okay, well, it's loading. It's crashing the. Okay, there we go. So the phase gradient is something you can consider it as taking a difference from pixel to pixel, how much the ground has changed. So over here is a gradient along the azimuth direction, which is along the track direction from Sentinel-1. And if you zoom in, oh, that's the epicenter of the 2 earthquakes. That's for the green star is for the 6.4, and the red one is for the 7.1.
And your frames that you created, you have both of them or just one they're separate? They have to be both of them together.
Excuse me?
Images you have when you made the interprogram.
Yeah.
2 frames at both the ends, right?
Yeah. The question is like whether these 2 images cover only 1 or 2 of the earthquakes. Yeah. The answer is yes, they cover both of the events. It's getting stuck, but if the video resolution for online people are okay, you see that there are actually a lot of cracks in this region, and you also have a bunch of them. The Jolla fault also moved a little bit from this earthquake, and you also have like over here, there, and there. These are all, I think, existing faults that get moved a little bit during this earthquake. So with that, then you can do a fault model. See what happened during the earthquake. This is only a result with very limited data for now. And the black dots over here are the seismicity. Then you sort of know, oh, that's the epicenter over there for the 7.1. And the 6.4 is something over here. But looks like there are like a bunch of missing shallow slip at the junction over there. All right, back to the slide. Here's an example for Oceanography earthquake, USGS. And it caused a lot of damage at Kathmandu, which is the capital at Nepal. And over here, what is plotted is the population density. So that's the darker it is, the more people there is, or more dense the population is. So here is Delhi, and that's Kathmandu, which is one of the places that you have a very dense population. This is the background tectonic settings where you have the main frontal thrust over here, and that's Kathmandu, and that's the Himalayas. It happened right beneath at a very shallow dipping underlying like Daglamong or something. That's a shake map over here, how strong the ground is shaking based on the feedback. And after that, we get this beautiful interferogram from ALOS-2 satellite. You see the fringes are quite clear, even though this region is pretty has pretty heavy forest. And then, yeah.
Why for this interferogram you were only 3 months apart, and for the previous one they were almost a year apart? Did you try other frames and they didn't work out, or?
You mean for the Ridgecrest airspace?
Yeah.
So the question is why the previous one I showed for the Ridgecrest earthquake is like a year apart, but for the Nepal one, it's only a couple of months. This is not really something that we can control. It's like JAXA acquire acquisitions at a certain rate for different places. Like for California, we have pretty regular descending scenes, I think, like 42 days repeat. But for ascending ones, it's not very often. Yeah, and they acquire data with different modes. Like sometimes it's strict map, sometimes it's GMTSAR. Yeah.
So at 12 day, it's like 6K
For ALOS.
for ALOS.
Yeah.
But we never get.
I think it was 14.
But in 14.
Yeah.
In Japan, they do.
Yeah.
It's like possible.
Also, they have much higher resolution data, like, I don't know, 5 meter or something. Then after you unwrap the face, this is how the interferogram looks like. So the red color means the ground is moving toward the satellite, and the blue means it's going away. So because it's a thrust event at a very shallow dipping angle, the red part is pretty much the slip pattern. If you do a slip inversion with this, this is what you're gonna get. It's pretty much directly imaging what the slip is on the fault. Okay, there are other examples. For example, here at Sierra Prieto geothermal field.
Can you go back to this slide?
This one?
Yeah.
Yes.
Where do you think the main slip was here on this one? You inverted this, right?
Yeah.
And where are the points you have the main slip on the top? Nice one. The size of the slip, how much slip?
How
big
it is? How big is it?
Yeah.
This is the color bar.
Oh, there's a color.
Yeah. 7 meters. Yeah. Okay, back to the San Andreas. So we are here at the corner at San Diego there, and this is the San Andreas fault. And if you go further south, or here, where the Almea-Cucapa earthquake took place, and there's a step over from the Imperial fault to the Sierra Prieto fault. And there's a geothermal field there, which is probably one of the largest geothermal field around the whole Earth. And if you constantly observe it with interferograms and build a time series out of it, and this is what the final like a velocity map, what we call, look like. So that's a Imperial fault, and this is Sierra Prieto fault. And the blue means the ground is subsiding at a very fast speed, which is more than 15 centimeters per year. And the subsidence is because they're extracting hot water out of the reservoir to produce electricity. And another funny thing is that if you go out there, you'll probably know that the power plant is somewhere there, and they're extracting water out of it. But the maximum subsidence actually happens to the east, which is right next to the fault. And this is a time series, how it looks like if you do a very simple batch processing and time series analysis. And that, other than that, you can actually also build horizontal deformation too and compare it with GPS. But I will skip this part. Of course, you can do an even larger scale analysis. for example, you can do it for the host and rest. But this is not only from InSAR. This is a combination of InSAR and GPS data. Again, the red means it's moving toward the satellite, and blue means it's moving away. These are all descending scenes over here in California, and the flight is flying that way and looking towards right. So if you just look at the color, it means this part is moving toward, and that part is moving away. So it's mostly a lateral motion along this whole region. And if you zoom in a little bit, you can see more details. For example, the Central Valley is going down at an amazing speed because of the drought and the groundwater extraction. You also have the uplift at the Santa Clara Valley. You have the creeping fault over there in Central California, which is really sharp on the ground. At a small step over, the ground is going down, like around this area. It's filled with all kinds of details. And that's one of the biggest advantages of InSAR. So that's pretty much it. Any questions? Yeah. Yeah, all the PPT files will be on the Google Drive. Also, one thing I want to talk about is that for this InSAR time series, I already put it online. If you go there, you go to the GMTSAR website over here, and there's over here, it's called San Andreas Fault InSAR time series. You can download the images from this link. So inside it has 3 products. One of them is the descending results. One is descending results. There's another one that we subtracted the GPS model from the descending data, and we call it semi-vertical. It's not really vertical, but it sort of reflects how much ground is shifting up and down. And after that, you find a place that you are interested in and input the longitude and latitude, and select your type of output, and you generate time series. You can get an InSAR time series out of this website at any place that is covered by the data set in California. Yeah.
So it's break time now, but before doing that, if anybody doesn't have GMT installed and working, maybe they can put their red flag up, because we'll have the GMT people here help you install it. But let's take a 10-minute break, and then we'll come back and learn about GMT. But oh, okay. You had it installed yesterday. Okay. Oh, you have GMT. Are you on Ubuntu? It's a new version. We have a Ubuntu expert here. What's up? Did you go to GitHub and then how do you install? It might not work on the virtual machine. You might have to get on the next machine. Oh yeah, you sent me an email. Somebody said you need all of a sudden it was fast live or something.
Yeah. So there's a specific library that has a different name. No, it's the same library. It's just like yes. Yeah, sure. Look, yeah, you can do it now. I mean, the big file works really well. For example, that one. I didn't realize it didn't work until I didn't have a history nearest neighbor program. And we compile and then I just made that neighbor file and compile it. Well, I think it was.
Yeah, try it. If you guys can work and getting GMT. But I have another laptop. My laptop right now. Are you in? Let's see. Yes.
No. I think it was that.
That looks like Windows.
So you already know one. So we're not going to you already have Google.
Okay. But I mean, which software do you want to use? That works. Or you already have that.
No, I guarantee it's a simple. Oh, so you have to. Okay, I see. Okay, fair.
Already have that. That's compiling.
Chelsea
So if you have
So then I should be already here. So you don't have to. I'm going to think it's going to be forward now, like over 14 times. We need to get those. Actually, you buy it. It makes you like you can see it on that was your first month in the jail. I went gradually up to about 500 a week. And it's still like I think it's the highest. So that's what most of us come to that series. No, what I have you. And after that, be behind the famous. But if you can tell me on it, let me know. You don't need it. Oh,
Now see you on 5X.
yeah, we install Xcode.
I don't know if it's installed or not.
Just like SAC. Just like
No, it's installed.
Xcode.
Oh, yeah, yeah. Okay.
Well, I can't look at the bash file very easily from here.
Yeah, let's look at this one, and then I don't know what's installed up here. But yeah. I think it'll work out. Yeah. It's falling apart. Oh, it's missing right there. Magnetic. Anyway, probably doesn't need much. So let me log in.
Yeah, but you have to unstar it. Yeah, okay, so that's your direct. User logo order. So you have it. So what happened? You run configure.
You could try and wait a couple minutes.
Oh, I don't know.
One of mine that jumped like jump over. He died. Previous to this one, yeah, this is one. It's like, now, but you have to start from the glasses, type of the glasses. But you need it. It's an old.
Okay.
I'll never do that.
You guys are back. Okay, Rob. So then I guess we can get started. So the last 2 days we had a GMT short course, and as I said before, GMT forms the back end of GMTSAR. And at some point you should look at some of these shell scripts, see what they're doing. Paul's going to give you an overview of GMT and talk a little bit about the modern mode of GMT6.
Good. Thanks, Dave. Thanks, everybody. So of these, what, 7 people, 4 are here. So I'm here, Joachim is here, Leo is here, and Dong Dong is here. So take advantage if you need any questions answered on GMT. So I only have what, half an hour, 40 minutes, something like that. So I can't really teach you GMT in a hurry. You should have signed up for the workshop we had the last 2 days. But basically, the sort of evangelizing message here is that to do GMTSAR, any quantitative geophysical science, you really have to start thinking like a programmer, whether you are a programmer or not, to see how you can optimize your workflow, how you can simplify things, how you can avoid duplicating efforts. All that stuff is sort of how you think as a programmer. And that's how we thought when we wrote GMT, and that's how Dave's using his background to develop GMTSAR. So, but if you're not a programmer, you can still help the community at large to improve all these tools by participating, by reading documentation. Maybe the documentation is pitiful, not working well for you. That's something you can help with, right, without knowing anything about programming. So we can all play a part to make this enterprise better. So GMT, it's been called Swiss Army knife for mapping tools. You can do a whole bunch of stuff. This t-shirt here says, it's not a bug, it's a feature. That's our motto. If you find a bug, it's probably a feature. We'll change it. There's a lot of stuff you can do with GMT, from data manipulation to plotting. And GMTSAR uses both aspects of that side of GMT. Basically, how we get things to work is to combine GMT tools, and often Unix tools, to achieve something that either tool couldn't do by themselves. So this is done by scripting. And it doesn't really matter too much what scripting language you use. I prefer Bash, Dave prefers C#, Leo did Python. It doesn't really matter too much. You should do something. Right? You can always change as time goes by. It's important to read the documentation and be careful what you do, because it's easy to cut yourself on these tools. They're very sharp and they're not always documented, and there's no safety switches on and so on. So you gotta be careful. So this is sort of GMT universe where we live. We're kind of here today. So I spend most of my life inside this box. Don't let me out much to work on the API and the C backend. And then Joachim is spending time over here. Leo is over here. Joachim and I are over there sometimes. But most of the time I'm in here doing the GMT command line. So GMTSAR is using the GMT command line through the scripts. But also it's using the GMT API from some of the C modules that Dave mentioned. Yeah, one more green thing here. So we're still work in progress on some of these. So if you go to the GMT webpage, the one that is not down, you'll see that the official release is 5.4.5, I think, which we released in January. And that version is fine for this workshop to work with GMTSAR. GMT developers, we're working on GMT6, and we have released a release candidate 3 a week ago, I guess, or so, that we used for the workshop the last 2 days. We're gonna time the release of GMT6 proper with a paper that's in review. So that's gonna probably happen in, I guess, a month and a half or something like that. So it gives us some time to do a release candidate 4 maybe and 5 and fix some bugs. But that's gonna come out pretty soon. Within a couple of months, so GMT6 will be out. GMT5 will be there for many, many years. But 6 is kind of, it's a hybrid release. It comes with something called modern mode. So those of you who took the workshop, you know a little bit about modern mode now. It's a new way of using GMT, but the old ways of using GMT is also there. So if you never heard anything about modern mode, you wouldn't notice anything different in GMT6 because it runs just like GMT5 does, more or less. If it doesn't, let us know, because that's the intent. There should be no change. But modern mode was our way to really simplify GMT to make things simpler. And if you have used GMT classic mode before, you know that there are a bunch of obstacles that are really hard to use to overcome when you're learning GMT. One is that you are in charge of building this PostScript file with appending to a PostScript file all the time.
And if you screw up one of those minus Ks or the redirect symbols, it all falls apart. Right? We've all done this if you've done GMT. It's very easy to do. You're going to edit the script, you forget the minus K. It doesn't work. Right? So most GMT rookies and experts waste a lot of time dealing with this. That whole process is gone from GMT modern mode. You don't have to think about that anymore. The other thing that's painful is having to specify the region projection again and again and again and again when you make lots of layers. And if you forget one, you get the wrong projection and things break down. And also it bulks up your scripts. It's a lot of unnecessary typing just to make things run. So that's all gone in modern mode. And the last thing is that we don't really want PostScript files. I mean, journals want PDF. Online, you want to put a PNG or a JPEG or something. So you always have to convert the PostScript file to some other product. And that's also tedious and requires a command. And some people have learned PS to PDF or some tool, which doesn't set the right settings to go script and it's not optimal. So we have all those kind of problems. In mono mode, you don't have to do that. The default is PDF. If you want something else, you just say, I want PNG. And all that conversion happens automatically. So I'm here to tell you that you should consider using modern mode going forward, especially after 6.0 is released. But you can also mix it up and use classic mode. All your classic mode scripts will run fine. There's no need to do anything about that. But going forward, you will see that you can save a lot of time switching to this mode. So if you're a user, you can find our GitHub page. And you can make contributions there of all sorts. You can post bugs, you can ask for feature requests, and you can contribute if you're a developer. I'm just going to talk a little bit about some quick dirty ways to make maps. Because at the end of the day, when you do the GMTSAR processing, you end up with grids that you want to image. So that's sort of the essence of the GMT plotting for GMTSAR is to make plots or images. So there's some few tools that you need to be aware of. So GRD image will take a grid and make an image. That's what it does, GRD image. You can get a quick and dirty map by almost giving no arguments to GRD image. And we'll see how that works. If you want some more control over the colors, you may have to work with something called make CPT to get exact color table you like and scale it. Often we want to do illumination on the grid to see. It basically highlights the texture of the surface. And then you may want to plot the color bar so that we can interpret what the colors mean in terms of elevation or whatever what you display. I believe this is still an active site for getting the DEM, so you got that for your homework. We'll get back to the homework. So quick and dirty. If you have GMT 5.4 something, you have something called remote data file access. So if you run a GRD image command and you access a file called @earthrelief_ and some resolution and either M and S, these are the choices for X. So 15M would be 15 arc minutes global grid, for instance. Here I'm running a 2-minute global grid. And I never installed this file on my computer, but by running this script, it will get the file from the interwebs, store it locally on your computer, and the plot will be made. Next time, you have the file. It's much quicker. So quick and dirty map, just run GRD image with the file name, projection. You don't even need that projection. You can even leave that out, and you will get a map up. No annotation, anything, but just a one-liner. But you'll see there's a couple of commands around this command here. It's GMT begin and GMT end. That's modern mode. So because all modern mode scripts start with GMT begin and end with GMT end, you cannot mess up running a classic script in GMT modern mode because those don't have those commands. So you have to deliberately choose modern mode by starting and ending a script with that. If you don't do that, GMT assumes it's classic mode. And that's how it's going to run. You can see here, there is no output to a file name that you have to worry about. There's no O or K, anything like that. It's just the command. And this will produce a file called map.pdf because that's the default output from GMT modern mode. If I wanted to make a PNG, I would just add PNG here. or maybe PNG, comma PDF to get both flavors. So it's automatically created in the background for you when GMT comes along. If you don't like just the default colors that popped up from the previous picture, you can use Make CPT. And Make CPT lets you get much more control over the color bars. So most color bars, if you use MATLAB or something like that, you know a color bar is just a range of colors that is matched to a range of Z values or something like that. GMT has a couple of features that are a little bit more different and more complicated. Some color tables have what we call a hinge. And a hinge basically takes two color tables and matches them together and positions that hinge to match the 0 point in your data set. So for topography, we often want to have a clear boundary between land and ocean. You don't want some gradient color right there. If you use those kind of color tables with topography, regardless of the range of your data, it's going to be scaled separately from land and ocean, but maintaining the hinge at 0. You don't have to worry about that. If you don't want that, you can specify to be equidistant about 0, of course, but having that dynamic feature built in makes it so much easier to scale and stretch any color table to fit any range of topography. Because you don't have to worry about, oh, I got to make sure the 0 is in the middle, otherwise it's going to put my color break in the middle of land or in the ocean. Artificial illumination. So because of the way we wrote GMT, we always had this feature where you had to supply the intensity grid or the shading grid separately from the data grid. So the data grid may be topography or gravity, and the shading may be some other data set like backscatter, or it could be derived from the topography, just looking at the slopes in the topography. So these were always decoupled because we wanted that flexibility. But for most applications, mapping in topography, you always want to derive the shading from the topography. So in GMT6, this is very easy. We basically throw in the -I option to GR the image, and you get the default is +D. It will create the shading needed from the grid that you're giving it, so you don't have to run a separate step. All right, so here, it's the same plot as before, basically, but I threw in a -I + D, and now you see there's a shading in the image. I also changed the color table to Terra here. I got a little different color table. And I threw in a base frame with grid lines. Again, it's a modern mode script. And you know, if you have a template for writing these scripts, the begin and end thing can already be preset. You really just fill in the middle. Placing color bars. That should be color bar. I typed that word 5 times, and every time Apple says, "Oh, you mean colorer." So, color bar. I couldn't fix it. I tried several times. Okay, color bar places a color bar near your plot. And in the old days, GMT4 and early GMT5, you had to specify where that color bar would go, positioning on the paper with, you know, centimeters or inches from some corner or something like that. In GMT5, 4, and so on, and 6, we can use the DJ option to place this color bar relative to these 8 critical points on any plot. All right, so top, middle, bottom, center, left, right. Use those codes and use that as an anchor point to place any map embellishment, such as a scale or color bar. And you can then also offset that from those critical points. So it's a lot easier to say, I want to put the color bar to the right of my map, which you just say, D, capital J, RM, and now it's going to be here. Instead of figuring out how wide is the map again, or especially, you may know the width of the map because you often specify that quantity, but you may not know the height of the map because that depends on the projection. So it's very hard to guess what is the distance in centimeter up here for some map, right? Because you have to compute that. It depends on the projection and the region. But by just using CT, it will go on top there. So a lot easier. So if you have done color maps called PS scale in classic mode, through positioning like that, better to change that to the DJ option. It's a lot faster and a lot more robust. So here's an example of adding the color bar to the right here. I say color bar, put it to the right middle, and annotate it. And you'll see There's no color CPT given to color bar because it will know what the last color bar you used were in modern mode. So I said I used Terra. That's a Terra. And color bar, well, he knows that I was using Terra. I don't have to actually do anything about saying that. So it's easily placed on the side. Here's a map that Dave and Eric made. They wrote it in classic mode. It's a somewhat complicated script. You will see this is sort of a typical end product, I would say, of the analysis. And it's a GMT map. You can see the topography is laid down first. Then there's this line of sight, definition. Yeah. Line of sight data. And then there's, there's a beach ball plotted for the 2 quakes. There's a state boundary. There are faults. It's a lot of stuff on top of the map. So there's many lines of code to do that. But it's not particularly complicated on that. And then there's a color bar. And this is placed in the lower right corner, but offset a little bit away from it. So Dave sent me this script this morning. It's a C-shell classic mode GMT5. And I rewrote it to 6 just to see what it will look. This is the output to 6. And typically, modern mode scripts are about 30 to 40% less typing. Right? Just the savings of not having to repeat things, not the savings of not having to specify output files and redirection and -O and -K and -P and all that stuff. All that goes away. Smaller is always better, less thing to look at, less thing to scroll, and fewer places to cause trouble, right? You can't cause the same problems you could do in classic mode, because if you left the -OK hanging there, it just crashed. Right? Now there is no OK. So if you want to, I'm going to add a little text up here or something, you add a command. You don't have to worry, where do I put it? And do I have to do O and K, or is it just K, or what's O and K again? All that stuff is gone, right? Just write that one command. So I'm just going to end with showing what that long script looks like now. So that script produced that pretty complicated map. So it's all fitting on one screen on a laptop. Just go through briefly what it does. You can see to begin, the plot was called demo, and I wanted a PNG. So that sets everything. What's the output going to be? It's going to be a PNG file called demo.png. The data image that we are mapping is this unwrapped LL grid. I'm getting a CPT. In fact, I'm getting 2 CPTs, one for the line of sight and one for the topography. We're doing a resampling of the topography to match the LL grid. And then it's a GRD image, 2 GRD image plots. There's a coastline plot, which basically ends up plotting the state line, I think, in this case. There's some faults being plotted. There's some lines being plotted. There's a couple of quakes being plotted. There are more faults, I think. There are symbols. There's the epicenters. There's a couple of focal mechanisms plotted. And there's some labels of these 2 quakes plotted. And then there's a color bar that is placed in the bottom right corner, this particular length and offset from the corner. So if I wanted to add some more labels, something like that, I just put it anywhere in this pack. It doesn't matter really, as long as it's on top of what I want it to be on top of. And if I want to take out, I don't want to plot this one, I don't have to worry about, now that is no longer the last command, so I have to make sure I have a -O or a K or something. There's only one -R, set the region here, and that is dictated by the file for the region. So -R is set once, and there's no -R anymore, because the region is known now under the hood. We know what it is. There's one -J somewhere here, Mercator map, 6 inches. And there's no projection in the rest, because it's all the same projection. I have to repeat it for the side of it. There's no O and Ks, there's no output file to PostScript. It's just the comments. And nothing is really produced in your directory until GMT_end comes. And GMT_end will say, you made a PostScript file, but you want PNG. I got to do this thing that makes the PNG. And in the end, it said GMT_end show. it will pop up the plots on your screen and using the viewer that knows how to view PNG on your computer. So most of us make GMT plots and we want to see the plot. So it's very convenient to enter GMT and show and see the plot coming up. And if it's not what you wanted, you can edit things and rerun it and pop up. So that's what I have about GMT6 modern mode. Dave gave you homework 2, I think. That had to do with making plots. And I think Leo and I are going to criticize them or something like that. Is that right?
Yeah.
Yeah. And there's a mug in the balance.
Yeah. The winner, we're going to have a vote. And so everybody take a sticky and vote for your top 2.
Ooh.
I think we'll go through them twice. So once get an overview and then we'll go back through them where you can do your voting.
Okay. So how do we get back
So
to?
vote for your top 2 and then the winner will get
back to here.
And that's like Leo's map is.
I think you have to go back one. Topo.
And Leo has a couple maps in there.
Oh, we gotta go.
And yeah.
Maybe, yeah,
let's start on them.
He already has a map.
Yeah, I think we can just start.
Okay, we'll look at your map.
Okay. So how do we know who's?
So how are we gonna write down? Should they have like a numeric order? Number 5.
We'll call this 1. But
we know the name. It's in the top corner.
Okay.
Really
Oh
tiny.
yeah, Alba.
So we're gonna go through them twice.
Yeah. Okay.
There are 2 of them that are named Alpha.
Ooh.
Ah, so are they the same Alba?
Yeah, it's just Davis is really boring and that's
Ah, okay.
I see. Yes, yeah.
Yeah, it's just the middle of the second.
Yeah, that's okay. So
where's this?
So this is Davis.
Davis,
People can step in and explain their map to us.
Yeah,
that would be good. So
tell us about your map.
Yeah.
Sure. This is the middle of the Central Valley. Davis is right about with those 2 highways come together right in the middle. Yeah, on the right you see the beginning of the Sierras rising, and to the left you have both ranges.
So what are these black lines?
The black lines are rivers.
But the really thick ones?
Oh, these things here. Is that lakes?
Actually, you can't remember what the big ones are.
Are they lakes?
Doesn't look like lake.
There's a lake there? You're from Davis?
Oh, maybe.
Yeah, so you should know this. There's a lake there? I haven't been there, so I don't know.
Well, the next one is less boring, right?
The next one is less boring.
Okay, so
Okay, yeah.
At the next one?
So
Yes.
This is my hometown in southern Spain, and you can see that there's a semicircle on top of that that's close. That area that looks like it's escaping to the ocean, that is a border. It's not a line that's rapidly plotted. It's a border between Morocco and Spain. The area is a semicircle. It's a small Spanish town in northern Africa, and that's where I'm from.
Oh,
okay.
Okay.
Cool.
The Rift Mountain, Northern Mountains.
Okay.
All right, so which color table is this?
What color?
Table?
This one is gold.
Blue. Okay. All right. So this.
And I adjusted the color scale. So I changed the upper and lower bounds.
Yeah. Good. Nice.
Yeah. I don't know if we have to make suggestions. I would say maybe add the color bar so that we know what the values mean using the new -DJ for placement. Yeah. But it's good that there's a scale bar at least, so we know. Next one. This is Lauren.
Lawrence.
Who cheated?
Yeah, so is this the algae bloom around the You live.
Lives on the boring island.
We all want to live there, but they don't want. This is the SRTM data? Okay, SRTM.
SRTM.
Yeah, okay. Cool. Right. You got a color table to go with it.
Yeah. There's a 1 arc second and there's a 3 arc second. And if you're making an interferogram of a gigantic area, go with the 3 arc second. Otherwise, it'll take forever to run. But if you want to zoom in on something, you probably want it.
That's always a good idea to make your plot with coarser data to just get it all organized. And when you're happy with it, you could beef it up and go to lunch, and it'll be fine. Yeah. But don't spend time with the 1 second data and then, oh, I have wrong color table or all the wrong regions or something. Waste of time. All right, Greg.
I don't know, do we have to say something about it?
You don't have to.
So Kilauea is right here. You can't see the mouse, but like right on my screen.
Kilo's over here somewhere. Here.
Yeah. One thing, so you could get rid of the pink ocean by clipping using PS Coast. So you can tell PS Coast to get rid of everything that's wet, and it'll clip out the ocean.
And then you could have PS Coast plot a bluish color instead.
Yeah.
So
yeah, you could plot something on top instead. Yeah.
Anyway.
Okay, now we have
you, Kim.
Yeah. Jake.
Thank you. Let's try with the Korean names.
And well, where is this?
Long Island.
Oh, right. Yeah,
yes,
I should recognize that.
Manhattan.
Okay.
East River.
And a lot of stuff is underwater here.
Yes, the Fire Island. Yes.
Ah, okay.
It was missing in GMT coastline back in the late 90s.
Yes. One thing interesting is half of the Long Island is actually under average sea level.
Mm-hmm.
So when I plot elevation for the first time, I looked back. I could scale it.
Ah, okay.
So you made the color change at -30. Interesting choice.
Yeah.
And were you affected by the large quake up here? Or? And you also have the extended color bar range here. That's a feature you can specify in color bar to say what's the color if it's lower than -3000 or higher than 5.
Yeah, so they have to put the triangles. That's an argument to PS scale.
Yeah, or color bar.
Or color bar. Okay, so we have Yao in. I don't know. Do you want to? How do I zoom?
CK right here.
Oh. Okay.
Very good.
Yeah. So we have at least one modern mode now.
One modern mode. And so yeah, so you masked the grid with the coastline and you did 2 grids.
So let's look at the next one.
Ah, yes.
So is this?
So what happened here? So it's the same issue that you had in Long Island.
Yeah.
That you had to set the 0 at -30. And that's because when you go to that DEM site, you actually get 2 versions of the DEM. One is the elevation above sea level. That's the one we normally think of as EM. But when you do InSAR processing, you want the height above the ellipsoid. And those are different by the geoid height. And so in San Diego here, the geoid height is minus 30-something meters. And so it's a strange looking map if you call 0, whatever. Yeah. It's minus 30 there. So don't get alarmed when the numbers turn out to be negative.
And so why are they black here? Did you limit the color bar, the CPP to go only until 0? And we have a weird pink stripe here.
What's this pink line mean?
Is that national border? Is that the Mexico border? It's not.
No, not there.
I think it's a PNG.
Is that the wall?
Is that a feature?
It's the wall.
Yeah.
Shows up on InSAR.
Very nice. 2 color bars too. Very fancy.
Okay. So we have is it Michelle?
Yeah. I didn't know this was a competition.
No one knew.
Mm-hmm.
Yeah. That's beautiful. The stripe with the legends there.
Yeah.
Pretty. Yeah, I like gray shade images, especially when you're putting stuff on top of them to show, because don't get distracted by all the colors in the background, but you still see everything about the shape of the land.
Yeah.
So it's nice.
Especially if you're drawing like another InSAR grid on top of it. Or, yeah.
You can even have the gray shading shine through with the PRD image.
It's transparency.
Yeah, so.
Now, Matt.
Oh, Matt. Hey.
I just think the, I think it was the geoid heights and a lot of stuff at the really low elevation. It's the same area. GMT5 and 1,000 problems. So
That's simpler.
probably no color bar.
Where's exactly is the whole house?
It's basically in the center at 32.5 and 117.
Here somewhere?
Yeah. Yeah, it's, you know, that's another thing I was trying to add was I think I was having problems with dash O, dash K.
Yeah, we all do.
Yeah.
We all been there.
Pirates, another code.
Yeah, exactly. So if you get a line that someone uses and paste it in, it
Yeah.
may be a disaster. Yeah. Good. That's a good example like that.
Yeah, and I like that there's the GMT trademark.
Yes.
The
We actually made 30, is it 35 cents or 30 cents each time?
Yeah.
It's 30.
Well, no, if you print a trademark, that's free because that's advertising, right?
Oh,
but if
that's
you
all
don't
right.
put it, then
there's
we'll
30
charge
cents.
you.
Yeah, sorry.
It's probably already debited automatically
Yeah,
when you
it goes
download.
automatic.
Okay, so Rob.
That's Rob. Oh.
My first experiment was in G6.
Ooh, nice.
Where I ran into problems was trying to get my favorite blue on the ocean. Normally I do prevent green blue.
Yeah.
And I think the dash S working with that. I don't know what I was doing. I went with cornflower blue instead.
So you
instead of my favorite.
We should look at that.
I think I'm just being.
So your favorite would be 3 numbers. That you know.
I spent a long time looking at that favorite blue. 305, 250, 125. So the square is where I work. That's a Livermore Valley. I work with Livermore and Livermore, and then the star is the Great Livermore earthquake of last week. 4.3.
Okay. So you felt it.
Yeah.
Definitely.
Well, actually, I didn't feel it, but other people did. And so I was walking to a building, and they were all running down the stairs. Actually, a report that some, it was last weekend. There was a report that someone's monitor fell over. 5% G.
Actually, I have better color motion too. I couldn't find it in GMTSAR, something like that. Color motion.
Okay.
So after you said that, you can set that.
And I guess the other thing is I just like having, I like having plain node around the frame.
Okay.
Yeah.
And did you turn off these axes?
Yeah. I always have problems with the axes with the new things I need to figure out how to do that.
Yeah.
I always go back to the old format and this things up.
The axes are a lot, one of the things that are also a lot simpler now. So
One new thing about axes in GMT6 basically is we always had draw the axis with annotations or draw the axis and tick mark no annotation. A new one now is to just draw the line with no tick mark.
Yeah. But
that's
it seems like every time I try capital S, capital W, and E, it comes out not the way I expect.
You gotta diagnose that.
Yeah.
Cool.
Okay. Now we have Justine.
So I was exposed to GMT about 3 weeks ago. So my current map looks a little bit better than that, but I'm from Raleigh, North Carolina, and this is like our general triangle area. To the east of Raleigh, we have the News River running through, so that's what that big purple blob is. You can see the watershed with all the darker shades and all the colors are just
What's another one?
I think it's the same one. I'm sure we can work to get you to a better place. Yeah. Yeah.
That should be easy.
But we know full well how painful starting out in GMT can be.
Learning curve is it's like a hard climb. It's not a rolling back. but it has the slope is now less, I would say. There's less obstacles.
Yeah, so there's an easier course that you can tread. No.
Just in you have these square in the foreign language. Okay. That's the way it works.
Now you have C1.
Yeah, that's a remote participant.
Yes.
Could make it.
So could you unmute and tell us a little bit about your map?
Yeah, sure. Can you hear me?
Yes.
So this is my living place, the Canberra, and the small map at the right corner shows the position of the city in Australia, and we can see so I downloaded this DEM data from the GMTSAR DEM generating tool. The elevation of the whole, we can see the elevation of the whole Canberra city is over 400 kilometers from the Calabar at the bottom. That's the Calabar at the bottom, yeah. And so most of the buildings and people are concentrated at the northeast part of the city. And there is a mountain at the south, or located at the southern part of the city. I guess the name is the Mount Anthony. Yes. And yeah, that's all the thing I know.
That's cool.
Okay, thank you.
The location map there.
Yeah, so yeah, I like the little location map. And there's now a new module as well in GMT6.
Yes, created by using GMT6.
Okay, yeah. So there's the inset module that will automatically place the inset.
I would like to hear. That's the inset.
Oh, okay. So I guess someone can't see Paul's gestures, but the comment was that the inset would be better inside the figure, so that you can hide away the portions of the data that you don't want to show. So where your model doesn't really fit, you can just put the inset on top.
Okay, thank you.
Thanks. Next one. I don't see any. Oh, here we go. Tanya.
that online?
She's online.
Is Tanya online? If so, could you please unmute and tell us a little bit about the map? Are there any comments on the?
I'm here. It's in Galapagos.
Okay.
Oh, Galapagos. Okay.
Okay. Cool.
Right. Yeah. Okay.
We can leave the chat
So
there
that
just in case.
Now a scale bar up there for the gray shade range.
Yes.
Frame would be nice. So those of us who
Yeah.
don't immediately know where this would see it.
Yeah. So adding a -b with the defaults would already at least let us know the coordinates. And why is all the gray here? I'm imagining that's a mismatch between the region of the grid and the region set with -r.
Possible, yeah.
One thing you can do with -r is give it the grid file name, and GMT will automatically get the correct region from the grid, so you don't have to manually specify it and risk either getting it wrong or having to change it all the time. Mm-hmm. Oh. Can you give it the grid name?
Yes.
Okay.
It could mean that there is not a numbers out there, not
Yeah.
data, and then it will paint it gray by default. It's more likely that. It
Oh,
could be
okay,
the same thing
okay.
here too.
Yeah.
Hard to tell. Yeah.
Yeah.
Good.
Well, we can investigate that.
Yes.
I guess.
Investigate. Forensically.
Okay, thank you, Tanya. And is that the last one? Oh yeah, there's. Which version do we want? Let's do the PDF. So. Oh, okay.
I'm happy that this is not a competition. You can see this in the product.
Yeah.
The day when I did it, I didn't know. And the place is Ensenada, is the area of Ensenada, Baja California, New Mexico. What I did now, I just decided to use it because I did that. And I was experiencing it.
Okay.
My first product.
Oh, that's pretty
Oh,
good.
good.
That's great.
So hopefully after the last 2 days,
Now you
you
can
can
have
update. Yeah.
fancy stuff,
Okay,
color
cool.
bars and coastlines. And, yeah.
And I decided to use grayscale.
Yeah.
And it's nice. You can see the places.
Mm-hmm.
Maybe in that small peninsula, there is a big old
This one?
Yes.
Okay.
Yeah, if you zoom,
Oh, like. Okay, let's.
there is
This here?
Yeah, that one. Yeah.
Mm.
It's important.
Yes. That's
Okay.
That area is an agricultural area.
nice.
And I think we have a new map uploaded. Here we go.
The late entry.
Okay.
in the competition.
Oh, yeah.
All right. Yeah.
Okay, so and Mohammed is online, I guess.
Yeah.
Yeah.
Phosphorus, right?
So would you mind unmuting and telling us a little bit about the map?
Hello, this is my map. It's fill shade of Istanbul, and you see the Bosphorus, and you see bathymetry data, and I was interested to see bathymetry more, and so I used the jet as a color bars. So it's not very conventional to use for bathymetry jet, but it's my experience. Yeah, that's it.
And where did you get is that one of the built-in GMT data sets for bathymetry or?
No. I got it from DT University. They have a global bathymetry, so I downloaded from that server. Yes.
Okay, thanks.
So the sea level, I'm just looking at the color bar. Should they get closer to red? Over.
Depends, I guess.
Sorry, I couldn't hear you.
Oh, yeah, sorry. I'm just wondering why aren't any red colors in your image, since the color bar goes towards red when it gets close to the code.
Oh yeah, but I thought that, I mean, for me it was kind of assessment of the data that I have. So because it doesn't make sense that the bathymetrists start, I mean, from 80 meters from the coast. So I just wanted to show the quality of bathymetric data.
Oh, okay.
Yeah,
that's fine.
Yeah.
Yeah,
Good, thanks. And I think those are all, unless there's any other last minute submissions.
We're gonna quickly go through them again, so we can vote for two.
Okay.
And vote for
So,
the gut.
And now, and I guess Rob or non-participant.
So,
You can vote for yourself, so at least you get
right.
one. And yeah.
So how's the vote gonna go? So if you vote for the one you like best?
Just put 2 names on the 2 names.
Okay. So first we have Ignacio. Left one. So okay. So let's do the yeah. Okay. So we have Alba. And we have Lawrence, Big Island. We have Jace on another island. So Yao is not competing?
Yeah.
Okay, sorry.
Sorry, yeah.
So we have Michelle's. Matt's here. Rob is also out. We have Mohammed's. And we have Justine. There's the Canberra by Siwan. Tanya, where was these again? Galapagos? Okay. And that's the last one, yeah. Did everyone, do we need to go through these again? Does everyone already have their favorite? Okay.
Okay, so we'll have the winner after lunch.
Okay, yeah, so we'll collect the votes. Yeah. I guess if we could pass the stickies with the votes to the side, then we can collect them at the end of the tables.
So, just a couple things about GMT again. GMTSAR will make some rudimentary GMT plots as you run it, but they aren't meant for publication quality. So I think that plot that Paul took from Eric and tuned up into GMT6, maybe we'll put that online. Here's an example of how to make a multifaceted GMT plot. Because yeah, GMTSAR doesn't do that. It does create AML files and PNG files that are handy to put on Google Earth, but they aren't really publication quality. They're great for earthquake response or something like that. So right now, what we should do is, lunch is going to come in a few minutes, and I think we have a break till 2 o'clock or something. Yeah. So by the end of that, by the time of the break, everybody should have their GMTSAR running. And then once you get it running, and issue those 3 commands that was in homework number 3, make sure it's installed. Then go to this website called, if you just Google Topex GMTSAR, there's this is sort of the main GMTSAR web page. How do I get? Let me run you through these web pages so you'll know what to do here. This is the main web page, and it just has a little bit about the history of GMTSAR and so on. You've all been to this generate DEM, and that's where you put in your coordinates and say, I want SRTM3 or SRTM1, and it will return a tar file, and you unpack that and get your DEM. One thing I should tell you about that is you see it's limited to areas smaller than 4 degrees by 4 degrees. If that's a limitation, what you do is you run it twice. You run it once with 2 adjacent areas, and then you can do a GRD paste and paste the files together. AUNAVCO. Okay. Man. Yeah. Okay. Yeah, we should put that into the, we'll put that into the, okay. Cool. All right. Yeah.
Virtual raster to put online, so you can just call that virtual raster. So yeah, you have the ALS world 3D, so you get the fuller 3D.
Wow. So for the online folks, Scott Baker was saying that Open Topography has a way to get the DEM through a command line. So if you're doing large jobs, batch processing, you don't have to go through this point and click thing. And we'll see maybe that later today.
Yeah, for the SAR, when you do a search, the DEM return covers all the
Okay. All together. Okay. Well, the other thing about this site is, yeah.
Is that DEM topography the same with the geoid?
Yeah, they did a geoid correction. Yeah.
Yeah, we correct. We did a littoral correction.
Okay.
Put it up there. And there's 2 options. You can choose which one. We have SRTM 30 meter, 90 meter, and then also littoral correction. ALS World 3D geoid and littoral.
Okay, so the other thing is there's a link to this GMTSAR wiki, and this is where the instructions for how to install GMTSAR, and it depends on the kind of computer you have. If you're on a Mac, you could either do it with Mac ports, that's my favorite. I mean, Homebrew, which is really simple, or Mac ports, or you could install it by using GitHub and downloading the software and compiling it yourself. One thing you need to do before, and this is in the homework, is if you're going to use ERS and NVSAT data, you need to download this orbit file, put it somewhere. I usually put it in user local, but you can put it anywhere. And then later on, when you install GMTSAR, you have to say, this is where the orbits live. This is a rather large file. It's 5 gigabytes. If you're not going to use ERS or NVSAT, you don't need any of that. So go to this page, and this is what you should be doing over the next couple hours, installing GMTSAR on your computer, first installing GMT and then GMTSAR. And this is where we'll have all the problems in the next couple hours getting that right. Okay, if you're successful there, whoops, go back to the GMTSAR site, the downloads, and down here, there's a whole bunch of sample data sets. And this is what I encourage you to always do one of these sample. Let's say you want to do ALS1. Do one of these sample data sets first before you even try your own ALS1. There's a little README there. It tells you how to do it. You can be confident that the software is working, that you get the right answer, and then go off and get a new data set. So there's all these different flavors of ALS1 raw data. Level 1.1 is single look complex data, NVSAT data, ERS data. And down here at the bottom is Sentinel-1, a lot of different varieties of Sentinel-1. One right here is this Ridgecrest earthquake. That's pretty, really nice to look at. It has a huge signal that Eric showed us. So after you install GMTSAR, then run one of these examples. Actually, I would encourage you to run one of the smaller examples first, like I think this one here. Wait, that's a good one. ERS or NVSAT, something that's not too large. Oh, and also, if you don't want to download the data, we have the data on these hard drives. One's for Mac, one's for Linux. So rather than try to sit there and wait for 10 gigabytes of Sentinel data to come down, you can get that. So, okay, so are there any questions about the installation? If you have trouble, put your red flag up and we'll try to come and help you out.
So the MDSAT seems to be like half a gig. Seems to be like one of the smaller ones.
Yeah, MDSAT would be good. There's an ALOS one. The ALOS 2 level 1.1 is pretty small too. Yeah.
Oh, okay. There was one that is like 50 gigs. That would take up.
Don't do the ALOS 2 ScanSAR. Yeah, okay. For 50 gigs, yeah. Oh, it's voting. Any more votes hanging around here? Let me get all the votes. Yeah. Oh, yeah, definitely. For the Mac, yeah.
Yeah. Good luck.
Yes. Oh, so you have to get that hard drive.
Yeah, if you go to GitHub, DC, yeah, if you go to the Wikipedia, GitHub.com.
Things don't need what
Are you the one signing that? So this is your copy.
One that eliminated water. Parking lot and so
So there's a MacPorts website, and if you go there, it says here's how you clean out all of this stuff.
it should be able to just yeah.
Okay, so they should shoot any other one. Okay. Yeah, so don't use that. It's gonna download the whole. Let's see what's in here for really long time.
So then you can just do approve this.
Hay un montón de comandos. No hay un comando que se llama GMTSAR. Un montón de scripts. Por partes. No sé cuál script tiene que hacer primero. Pero hay todo donde yo lo instalé, pero los scripts están debajo de ti. Si te vas al homework set, los comandos me corren, pero no me dicen what. El homework tenía los comandos que había que hacer. Y cuando yo hice los comandos, correcto, no. Mira, InSAR. Voy aquí a mi home. Estoy en mi home ahora. Comando GMTSAR y te sale. No, nada, eso no es un programa. InSAR. Vegetarians might be, if everybody eats vegetarian, then it gets complicated. There's vegetarian there too. I typically wait to make sure that I don't have any preference. We're close, but not quite.
Vegetarians or vegetarians or anything labeled all of these vegetarians only that like life or definitely non-vegetarian. Oh, yes. Everything on.
You don't need to.
They have napkins there too.
Yeah. Oh, yeah. Let me give you the password. Well, I'll just write it down over there. I don't remember how whether that has not worked on the. Yeah. I go to the wiki and then I look. Oh, no. Okay. Yeah.
Yeah.
Oh, the movie, yeah. I'll look at those. It came out okay? Did the outro slime? Send it to Bridget. Yeah. Yeah, I saw that.
Yeah.
Yeah.
So,
oh, yeah, that's
yeah.
Yeah. Yeah, look at mine.
Yeah.
That disabling job. Jolla got one that was
Yeah, that's tricky. This thing is yeah, I guess we were trying to move the nasty with
and SLCs. Think you're gonna trust them?
especially for the direct outflow.
I wonder if they're gonna run this one over in the oh yeah. We went up there after couldn't get on the base. It's a gigantic base. And all the most of us I got it.
Oh, yeah, one
Want to use one of these discs? Then you don't need to download it.
Well, I just downloaded the empty set. It was like half a page. Just download it quick.
That one you need to work.
Oh, the orbits are already downloaded. So there were like 5 gigs. I mean, everybody downloads that now.
Yeah, those guys, yeah. Everybody went out. Learning about it. T-shirts and
Oh, wow, it's doing something. Like I'm cooking with gas. Typically, users kind of like the download. We can code like a private development, and for that you they will give you support. And they have a private system,
And that's approved by
yeah, it's Microsoft, so they're familiar with that. So back in the day, probably was not as clear. They provide like support for server configuration. If you want to host it not in the cloud, but in your own space, you can do that.
yeah. Wow.
For continuous support, it's like $250 per whole per year.
For the Linux. It's not too much. But that's the one you have to use.
Yeah. The only problem is like some of us that if you do developments and then you do like stuff for like operation, then you might end up with 3 bugs. There are not isolated environments. So that's like close to 700 per user, not including the hardware and the parts. We used to use software for a long time. We liked them. They were like the thin client. They connected to a Sun server, running Solaris, and I mean they were pretty cool. Like in the sense that they don't really that much heat. I mean, it's the new books they get fought. I think when they designed the building, we just go to a new building. They didn't consider that everybody was going to move back. So they had to do some rewiring of the circuit.
I really like those old days where you had one central server there all the software. Everybody just did that. Now we have a copy of multiple copies. I can't figure out what's going on.
Yeah, so this is what I did. So I use Current. And I use the MBSAR. I downloaded MBSAR on the first one. Oh, Baja, I guess it is. Baja, oh, it's incomplete. It should be like 600 pages. I still download it. Oh, okay. Yeah, I think it's almost done. Well, you have more boards that I you have to do a presentation. We could try to download it. Where's Oregon? What is Mauna Loa? Yeah. It's too bad because you learn more that way. What's the rest? So along the track, but in the range direction, the way process it, we usually do 8 looks in the range direction. I mean, how do we do it with a filter? So it's sort of 2 paths. It's like one path that's automatically done, and then we just file down offset.
Almost everywhere. The Western U.S. is underground water signal. Remote code. Okay. We looked at one in China when we were visiting China, and Beijing is going down. Underground water. Almost everywhere. I saw somewhere there. Yeah, you gotta pick one of these. Run one of the sentinels, and then run one that has the frame. We'll make it all on. It'll take all three. You know that one. Download.
Are we going to make an example where we're going to be not downloading the file ourselves, but setting, you know, or
first I would run the
running the hello world.
So after you run that, and I would just take off. Well, that would try to because the sentinel, especially maybe yeah, the sentinel tops. Maybe that one's good. There's a swath mode, but they don't use it anymore. No, there's a very narrow swath. Try Los Angeles or Ridgecrest. Either one. That's a new one. That's sort of fun. And once you get that one working, then you see you just need to download 4 files. I love the same copy.
Well, that's 5 gigs.
Oh, it just means that. Well, we're not supposed to distribute it. It's really serious. We don't have much power subject.
If it's a photo of one of the Linux hard drives, what I can do is the Ridgecrest is like 5 gigs. So I'm not going to
The Ridgecrest one has a whole framework, and then it has a small area where you go high res. Both examples.
And they have the digital elevator already.
It's already there.
Mac is probably the best. The Mac is probably the best file system. I think you have to play this one on a Mac. Not the other way around. Yes. Oh, yes. No, it's still running the corporation.
Oh, I see.
Takes a while. I don't know. I have not been looking at it for a while, but it's just jogging around. But then you look at so he recommended Ridgecrest. Yes. So now the
Right, so. Yeah.
I think the other one. So you're running it now.
Yeah, I was under Yeah, I thought.
Oh, yeah.
I'm doing one of the fellow works. This group, they make everything, so it's hard to learn. Because you're not suffering. So they're
We're waiting for break.
After my
advisor, he learns that his advisor actually kept repeating that learning is through pain and only through pain.
Yeah. This is a lot of
couple lines that
I was trying to get up. So I think it's really big correlated. Yeah, well, I got it.
Right now. Oh, yeah.
You have to depend more like on contact. Yeah. For stuff. Before you could just build stuff, but I used to just paint in my iMac. I still use it for little stories, but I'd rather build it myself because then if I have to put in that to work,
right,
I know how to build it.
Yeah, I put in your CMake. Should be somewhere. But I like to configure script is a lot of work for you. Trying to unmount right now, and it's giving me the wrong this. Yeah. Safely remove. There we go.
I can read that.
You should be able to read this one. Oh, this is USB. You need a Thunderbolt. But I think he has a one-way manual.
When you ran it, it's running its.
What it's doing now, Rob?
Usually I type the output.
What? It's doing surface now. So this is the GMT.
Yeah. It's interpolating a 2D grid of elevation points.
Okay.
Oh, you ran the repeat. That's good. Yeah.
No, but here's the problem is
All the sentinels are pretty big.
Oh, yeah. I think it's just running. Okay. And so the zero needs to do subslot F1. Because if you had enough CPU, so the top search running that.
Yeah, sometimes there's
just take a break for an hour.
from here to the beach.
Where that construction is, you can walk down that ramp. Oh, there's a ramp.
I never said my Pacific Ocean.
Oh, you gotta do that.
So I gotta do it.
Is your job running?
Yeah.
Just let it run.
Yeah. It's now doing surface, so I don't know how far.
Here's the plan. What's my lower priority, so it'll take longer.
Oh, yeah.
It will take longer.
Rename. Surface takes a long time. Which example are you running? The MBSAT?
The MBSAT. So I ran yesterday the code that you mentioned in the homework, and they just printed information to standard output. So at least I knew that all the linkage was good, and they were in my path.
Usually I type the output of all these. Can you greater than ampersand?
You see, so you have to do the T thing.
Another ampersand like that. And then if your terminal gets disconnected or something, it'll just keep running.
So what is the second ampersand? That's for standard output, then standard error?
Yeah.
For both?
Well, some of them have the standard error. The ones that Rob wrote are all standard.
So for some, we have to use I forget how to use it. Greg Wagner, he's the one that always uses it. So he would speak standard output and standard error to your terminal.
Oh yeah.
But also would send it to a file as well. Let's say
T. I forgot. T. I don't remember.
Now we all took better notes before Google.
Yeah, I know. I just Google it. I'm hoping I don't have to sit through a couple to Australia.
Oh,
yeah. Five sticky, 5 different photos.
InSAR plane. Oh, I'm sorry. No, it's flying the surface. I'm just reading the user manual. You go to this website, you go to download the PDF from there. Actually, I had a free time to have brought it. I left it out. Oh, wait.
Yes. Yeah.
Sure. Yeah. Yeah. Which
I think September 3rd, 2017. I'll check here quickly.
Okay, put in the video. That was already in there. Because did you use homebrew? Yeah, so homebrew already. Somewhere in there.
Yeah, 2017.
Yeah, do it on that.
September 3rd.
These are all both standard.
And the other one was September 9th, 2016. I think for that one, we got it for January 2016. That's the bigger one.
So we'll do the dates for 2017.
September 3rd. 2017.
Okay.
And it's also 150 pages.
Maybe
By law, the framework.
I'm just counting the votes and then I'll.
Yeah, I have them listed by too many.
Oh, I can tell you because the SAC data are included.
Yeah, I know. I'll just grab this file.
Okay, then 2046. 2017 to 246.
That's you unpack. Oh, you already ran it. Done. Okay, so we didn't explain what all these results are. So in the, okay, let me explain the directory. There's a directory called log. These are directories. There's this one called public, that's where you put the public. And then when it runs, it creates an SOC directory. And then it creates a signed TF directory. That's where all the interfile is together. And then there's usually sometimes we'll get really down to I went to this directory. And then all these files here. There's anything that's like correlated. Coherent.
It started with
And this is in range now. So it's a little upside down and backwards. But that's the yeah. See how it's a little darker on the edge? That's because that's the end
oh yeah,
so anything with an LL.
it was done.
So in the file, oh yeah, I just want to know. Usually you need it so it doesn't try to take out. So
that's where it'll.
Choose your points on how something's gonna
So you have a deep, DEM, right? Let's say we want to have some point. And you fly the spacecraft by that point, and you find the minimum range. We call that the range. Climb up there.
That's why they said, I think this is
so that accuracy, the only inaccuracy is treated in a way. So it's just a proof of work. When the orbit's really good, we don't need that. It makes life easier. So this is all working. So I would download. Once you download all the other here we go. Accept the terms. You don't accept them. It said that they can plug your house and listen to the conversation. Yeah. Siri in your house. That Siri's job. Yeah. The other thing I would do over here by default, Apple doesn't want you to know that they're they have to say, oh yeah, I want to see what my disk drive is. People don't know what they are. That's show your hard drive by default, so now it's there. Secure your hard drive. Yeah. So why would they not show your hard drive? Yes. It doesn't actually work. It's in utilities. They're buried in there. No one in the world has ever wanted to.
Yeah, it's running.
But that was the one I was running. Okay, so then.
InSAR back in the day when sports like was expensive for something to cost.
Then there's a filter. Oh, yeah. I filter when it comes in. Yeah.
Where's the one way to turn that off?
You can turn it off.
You can?
Yeah. It's in navigation. Do not automatically tilt while zooming. So annoying that does that because you can't get it. Yeah. So, turn on. See, it opened up all these things. So, yeah. So you can look at that and then go on to the Sentinel.
KML was that one?
I just opened all the candles. There's four of them.
You started the other one?
Yeah. The phase filter is just filtered with this bulk filter. And the other phase is filtered with Gaussian. Bob programmed that one up. Works great.
You raise the system exposure, and then you do reverse or weird non-linear filter.
Yeah, but nobody knows why it works.
Yeah, you can actually raise the, you can fix the way they bring the code forward. So it's a non-linear.
But we have the same parameter for alpha and
yeah.
to make the same percent of that we could use for structure.
Yeah. What are you thinking? The phase from the photograph?
Yeah.
Before doing the
Spatial.
analysis?
Yeah. So the fringes appear as a sharp beat.
Am I doing the one that I
I've never done a 2D yet, because for FFTW again, constantly.
Yeah.
Although now we can
Because there was a
the T1.
On the Mac, oh yeah, GMT uses whatever one is best. So on the Mac, it's built in. That's all then. So try the one of the Sentinel ones now.
Oh, that's how you separate these. Once you find the subject.
You could come densely see that I need to spend $2,600 on a laptop.
Yeah. Yes, half university.
The kids, they don't need to be in this one. My AML short. Oh, there's some PDF. Yes.
Running the piece and I run that deadline. That's a
Surfaces. Yes, putting the D in.
Sorry about that. The Australian one is really good. Yeah. I voted for it. I don't like having
Typically, what we do is you put in evaluations. What?
Oh, it's like riding a bike. Like riding a bike.
No, never. No, I'm done. I didn't want to.
Yeah, the whole service, InSAR.
I'm trying to install Homebrew on this computer at night. It's not working for me. Did you use Homebrew? I think there's a permission problem. Yeah, you went to that website and copied that line. Yeah, did you have to be super user, sudo, or?
Yeah, I was
You went to root. I'm going to try being root. Okay, and then
This you can get from no.
Huh.
Oh, there's a link that I had to do it from the website. It's a Ruby script.
I did that. It's just that it says it works, but then when I type brew, it doesn't come up. Maybe it's not on my path.
Yeah, that's probably it. It's under op local, I think.
Oh, that's Mac ports.
Oh,
Mac
that's
ports.
oh,
Yeah.
sorry.
Command not found. Hmm. I think it was installed here before and it got messed up and I need to reinstall it.
And that's the same path that he has it. So it should be in user local bin.
That's where brew is.
Or yeah, it should be there, but obviously it looks like that's odd.
Yeah. I'm gonna try to remove all homebrew.
Why do the correlation plots from InSAR almost they look like visual, like optical imagery?
Yeah, because it's like farms or no farms.
They almost look like optical, but you would see
Yeah.
so it's surreal.
So like in here, this roads with houses.
Oh, yeah. The mountain.
The radar waves don't even stand there.
Almost look like Oceanography.
So is that, that's the end exam?
Yes, finished. It was still putting out the PDF. So, oh yeah, now everything's finished. Because the KMLs, they were not there. They are now also.
Yeah, everything's true.
This laptop is i7, but it's so old that this laptop is i7. Looks like yours, but yours was like at least twice as fast. Right now,
Okay. Hmm.
I think the initial installation
As root? But it doesn't say that.
Well, it doesn't hurt to try.
Yeah. Oops. So I did that command and it looked like it was installing. It did. Let's see. And this and then it Roof made writable. Oh, it's the JIT. Git. Maybe if I delete that file.
It's probably already in there. Did you have Homebrew installed on
It
this?
was before, and it was under a different user.
Yeah, then you need to delete the .jit.
Okay. And just try it again. Maybe.
Yeah. Do that, and I think you'll be fine.
Yeah.
Oh.
No such file directory.
Oh, you're running refresh? That's the one I'm gonna run.
There's no file now. Maybe just run again. I remember I didn't have to be root to do this.
Try to just wipe the whole Homebrew.
That's what I did. I went and did the uninstall.
There are a couple of other directories you need to wipe as well. You need to get rid of the task room and the cellar as well.
Oh, okay.
Task room, cellar, task room,
Sí, pero no va.
cellar. There was a command that would remove all of Homebrew, but maybe that didn't work.
No, I had the same problem getting rid of Homebrew as well.
Oh, really? Okay. Try it again?
Yeah.
Dang. I didn't think you had to be root. I don't know why you don't have to be root, because it's doing all kinds of things. Whoops. Oh, bash. You have to do it under bash.
User local data, GMTSAR, or
This looks a little better. Yeah.
Yeah.
Okay.
Okay, there you go.
Thanks.
No lo bajo, si lo bajo aquí, se va a tomar tiempo, no va a estar tipo. Descargaron los están ahí. Se va a tardar 45 gigas. Espero que acabamos. Porque esto baja rápido, pero es lento. Porque trata de enviar
Yeah.
Please, do you have
The data, yeah.
For, I'm on Darting it. You want to get a quick look at it?
You have a Mac or Windows? You can mount this in there to make it work. Oh, yeah. Thank you.
books and trying to.
Oh, you trying to solve?
Number is still right. It's wild. Just so the GMTSAR we have the home site. Sorry, crashed. Oh. Well,
Maybe I'll change the permission on that file.
I think the problem is that
User
you,
logo.
you have something in there already.
All of Eric's, yeah, he installed it, and when I uninstalled Homebrew, it probably didn't move all the stuff.
So you probably have all the links in there.
And they're owned by Eric.
Yeah.
Because he had this, so I could just change the ownership and user local.
I
This,
think it is still complaint.
yeah. Let me go into user local and look at one of those.
I have to find a little trick to locate all the dead links and delete them.
They're owned by staff. That's good. That's this, I mean class. We're trying to install GMTSAR in this, and you were the owner before. You probably used Homebrew, right?
No, I didn't.
Oh, you didn't use
I
Homebrew?
think you installed it while you were creating an account.
This is my old computer, and so when I did it, oh, there it is. See all these things? These are all owned by me.
But you don't have a user account.
I don't have an account here.
You probably want to change the ownership of those
Of all these to class.
The
to root or whatever.
easiest way, I think, is to change the rights for the whole user local tree to allow everyone to read and write.
Okay. But I could, it's having trouble in bin right now.
Yeah, but there will probably be
The other ones.
more links that it tries to create.
I'll do this one right now.
Oh, thank you for I don't like that being supported from here.
Like that. Just see how that works. Oh. I think I should just try it again.
Yeah, you can.
Through.
Yeah, I think it should.
It'll get further.
left off.
Then it might go into the live and have the problems or include something like that. Oh, this computer was owned by a number of people. It's sort of a hand-me-down. I wanted to run one.
Also, I didn't know that the icon is actually looks like an IPA. Yeah.
Homebrew's good.
One thing that I learned the hard way: do not install both ports in the Homebrew and SAT.
Usually I wipe everything and start fresh. Oh, this looks better. See? Okay, now it's running. Sorry.
Also, GMTSAR 5 is in Homebrew.
Yeah.
Okay, but it will not get a dependency. You have to do the dependency.
Just like make does everything. Yeah. This is for the earthquake. Wow, that's cool. It's doing crazy things. It's because if you're outside of where there's good GPS coverage, where does the GPS end?
Green mag
Are there any observations over here? Yeah. Wherever there's an observation, it'll be okay. You need to, you could do a mask based on the density. Well, that's pretty good. But this is trying to create the smoothest possible deformation field, but there's a fault there. It's going to have trouble. That looks pretty good. What's the time So the Earth moves in 20 days on here. Oh, because you're in the ITRF.
It's in NA2.
Okay. Really? They did. Wow. That's pretty good. Those crazy things down here. You could use fewer eigenvalues. How many did you put in?
I just used
Oh. Okay, so
we will have SSH for SSH somewhere.
I just follow.
It looks like it
800.
800.
And how many data points do you have? 650 times 2. Make that 400. Works when it's about 1/4 of the number of total data points. I'm going to run this GMT thing. It looked like it got a little unstable. All right.
Yeah, it's better, but smoother, but they
It already
also,
ran? Wow.
But they also cured this.
Okay, because it couldn't capture that sharp. So you'll have to vary the number of eigenvalues. But is it better down here? It's not doing crazy things down here. Wow.
So they want to fit this and this changes.
Yeah, it's not because it's a crack in the earth. It's not a good model for this. But maybe there's a parameter. Yeah, sort of. But it's really just each one of these cases, those are the best parameters for that. It's going to do all three so far. This is the Los Angeles one. Yeah, the Peterson frame runs 3 times once. Runs all 3 and that stitches them all together. So, but there's an important thing here. So here's the wavelength. Okay, 160 meters. That's good. You can make it shorter if you want. Yeah. And see this destination factor range. You have to set those because each subswap will have a different sampling. And when you switch them all together, they all have to have exactly the same. So that's why. So you can change those numbers. If you want to get more resolution. Make everything start. Actually, these data are really, really good. And so, if you go to that example, this one's good for the whole frame. But take a look in that direction. Go in there. It's just going to process swap number 2 while you're yeah, look at that.
Yeah.
Yeah. And the filter way left. If you had run that with the whole area, it would take hours.
I went to the read, and there is a main.
There's also a parameter in that in the P2P frame. If you at the very last parameter it says, "So I want to run 3 in parallel." If you don't have enough memory, you have to run 1 at a time. But I think you can run 3 in parallel. That's a fast computer. It's really fast.
Already the IO, so bottleneck, and here it's like insanely.
It's a solid state disk. It's really fast.
Look at this.
Beautiful, huh? Yeah. That was done at the low res, and you get the high res.
So why it's so coherent? Is it because the area is
It's only 12 days in the Mojave Desert.
And it is strike slip, no?
It's a strike slip, yeah.
That's why it is.
Yeah.
No question, what is the plane here?
Now my next question is,
Yeah. Ask Eric exactly what you would do it. Yeah, you can dump the data. You might want to not dump all the numbers, but dump every 100 or something. But then you need to look at it.
Yeah.
So there's a command called stat.
So you would deal out to some kind of.
And then you make an ASCII file on line of sight definition as a unit. And then you can do models. Yeah.
Is there a script on the GMTSAR to clean out the products so that if I download a project that has output, it will download it?
Yeah, no, but if you make a mistake, if you don't know what's going on, you go into that directory and you say cleanup.csh space all. It'll clean out everything that's not relevant or essential.
So as long as you follow that directory structure, like raw, topo, it will leave those.
It'll leave the raw topo and delete the SLC and the INTL. Start fresh. Yeah, yeah, clean up.
I didn't do enough copy. Not that one. But the read has the read here for you.
In the Ridgecrest? No.
There's a maintenance part that we need that is not commented on. I'm assuming that I have to go and say that. This is the different.
If you didn't have it.
And then the top of all the so this is what makes them all right.
And when you before you run it again, run this. I guess you can just run it.
Let me try this. So that with the minus all minus. Yeah. And you have to change. I see.
Huh. Oh. Oh, sure. Did you find the orbits?
No. The problem is in my lab in Ubuntu.
Yeah.
I am installing, trying, but no installing, no installing in my Ubuntu version 16
or
4.04.
It should work. Yeah.
But I have a problem. I don't know why.
Okay, I can look at it.
You
yeah.
help, please?
This is running here. Yeah.
But again, this is what it
Wow. And this is also.
I'm not very good with it.
I speak Dutch.
Yeah, that's right.
Bigger than that. InSAR. That's
whatever is in between that.
InSAR is one of the. Would make sentinel codes and InSAR. So I don't know why.
Okay. And you have orbits.
So you can, or you can
Enough data.
Well, we all have.
I think it's good.
Yeah.
No, did you make it yet? Did you make it? Yeah. There we go. That's good.
You can your method without worrying about the regions settled down. I would start with it.
Yeah, these are all the code. And then we're to make install.
That's why I using Anaconda. You can take Anaconda for Mac, and then you can do Conda install. Anaconda. That's correct, but it's a package manual, so it does Python, but it does also C and C++.
It could be the path, but I think.
I got the command somewhere.
Where did you put it? User local.
You should try to install Anaconda. The expert is here. He has a lot of detail. What he made, I just wanted to realize that's what we use in the installation. This first one is
We could go there.
my machine is
Just not, yeah, right. Oh, yeah. And then everything's there. Did that work? Oh, yeah. Oh, yeah, because it's all in your path. Okay, so then, are you running bash or do that? Hot bash or that fine. Yeah, the dot bash or yeah, so you would add, I don't know how to do this. Yeah. Exactly. And then you have to log out. And then save it. Now you need to log out. And then get a brand new window. It'll like every time you get a new window, it executes. Not like
there and they got like David. It's not gonna be easy. Use
install that.
Let's go. He was hesitant because he was kind of like, you know, no, like you have nothing else. No, that's fine. You can use it.
We're gonna have to uninstall.
It's at in his office, of course. It's a beautiful thing. And it had a large window. And you could see the pastures. You could see the sheep like moving around. So like. There was something.
It's okay. I can search
of the building, something, pineapple or whatever. And they would work a minute. Yeah. They would go there for.
I'm gonna make it smaller. There you go.
Yes, I got it.
We need to uninstall. Studio get uninstall. How do you install GMT?
So I have a really
Oh yeah, yeah. Maybe it's not GMT. Sick. How did you get sick? Who did that? How do you install it?
This is just getting all this
GitHub.
stuff.
GitHub, yeah.
Yeah.
The other thing is like I have a whole thing of stuff.
So it's the net CDF.
Is getting the format of the data. So as long as you have all of it, you can read that. But when you get to text, you already have latitude.
That's not going to solve it.
Be the symbols.
Really?
And the symbol.
Or it does GMTSAR.
This is, but that's okay. So as long as the different columns, there's a column minus 4.
Sure.
That's what you just want to find out.
You send the picture. I think you would appreciate
Problem
it.
is net CDF.
We're far from home.
They can uninstall net CDF. Let me ask you that. Yes, the problem with installed InSAR. He had the wrong net CDF. If he has the right net CDF.
That one doesn't work with InSAR.
Maybe he has multiple nets.
So is that is it in the CMake? Is it CMake?
Yeah. But how do we finally uninstall?
Depends on how he installed. Yeah, if you did ft-get, yeah, then you can ft-get uninstall. Yeah.
And he must have installed MP6.
No, he only got binary. At least we weren't telling people that.
Oh, okay.
If he did the Conda version, the problem is that if you Conda uninstall NetCDF, it's also going to uninstall GMT. It's a dependency for you. So I can't just remove NetCDF and leave a broken GMT.
I suspect there are multiple nets.
You can usually tell CMake where to find the net CDF. At least you can for the div build, yeah. I don't know if that has to be configured by someone at some time or if that's
That's how you install GMT.
Yeah.
And that automatically installs NetCDF.
Yeah. That'll get NetCDF and Val and all the entities. So do you have what's that? There's an NetCDF program. What's it called? NCView. So if you do which NCView, you can check.
That's not NCV is something really.
But at least we'll know where it's installed.
Yeah.
So if there's the Honda version, it's going to be at some blah 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 Honda.
Okay. So it's
maybe we can run this config. It's not correct, yeah. So
The problem is when there's a problem with the connection, you might have to start
yeah. How can you uninstall?
They're almost aligned. That's my point. But that's what your history is. So my point is that. Okay. Noise cancellation.
You have to be rude. Remember.
That's why, yeah, it shouldn't try to remove this if it didn't even. That's it. I don't know, you know. Yeah, I don't know if we can. No, it's no, favor.
Yeah. Your name. What's your username? Username.
Okay.
Great. Yes.
Let me know.
Never met them.
These are further closed in than the previous one. Are a little bit closer in.
Yeah. We just ran the config again to see what Schnitzky you have to get it. You can make that bigger. Scroll back up till we find the net CDF.
Oh, this one.
Yeah, move this down. Okay, you can-
Getting used to this part, or you don't get from that. Usually, yeah, that escape very much.
Oh,
we try to run pretty good.
Yeah. So then we can say make and make it. It's only when we go to run it, there's a runtime line where you can
Oh.
Yeah.
Then it says something like can't find shared library.
Yeah. Yeah.
It is finding the Congo library there.
Yeah. Run make it run.
Because GMTSAR doesn't use GMT, doesn't use that CDF directly, right? Through GMT.
I think so. Yeah. You know, we were running it before as Ruby. We're getting off the point. Right now, we've changed ownership, so he owns it. Maybe the path of Ruby. Right stuff.
I don't know.
Good work. Now, you might have issue problems here. Yeah. Okay. Oh, it's working now. Yeah. Before it was down on my phone. Maybe because we did it all as a group. This time we did it.
Oh, yeah. Yeah, that's the problem.
Okay. You want great things. So I'll get a data set. Okay. Almost time. Hmm. Is it working any better?
Yeah, a little bit moving now.
Oh.
I
Yeah,
have a
moving.
lot of noise here.
Doing something. Yeah, it's a long
try
valley.
to fit that data here.
Yeah.
You see the green?
Yeah.
And around. And
There's going to be an earthquake.
yeah.
Wow. That's good. That's a 6.4?
Yes. But I still have some kind of cold here.
Yeah. Weird. Wow.
And precisely.
How many eigenvalues did you use?
I used 500.
500.
Maybe I should reduce it, right?
I think it's having trouble fitting the very sharp fault and the things far away together. Because it's not made, it's made for an elastic solid, you know. Doing crazy things down there. Huh.
Yeah, I'm gonna keep trying this module.
Yeah.
Also fuse technique.
Is it working?
It's running still. I was looking at downloading data. I've never downloaded central data.
Well, do you want to get someone to this here? Or do you want to get your own example?
I have a specific area I want to work with.
Okay.
Which I thought you would have. Because it's
Yeah. Yeah. So when you do your search over here, you make a little box.
Yeah, I made that and then I click search and I put all this stuff.
Yeah. So come over here. You want only Sentinel-1. And then come over here, a certain date range.
I want the longest range I can get. These are basically
Okay. And then over here, put product type and SLC. And sensor mode, IW. And what it's going to do, it's going to find all these different scenes that are just overlapping. So then you have to click on one of them and say, what track do you want? Then you'll do a search again. Yeah, this is strange. No, it's not. I don't know how to get out of that mode. Yeah.
I'll try that, but I'll keep it ready.
Yeah, actually, Scott's going to show us how to search for Sentinel data.
Oh,
she wants to learn how to search for Sentinel data in Utah. Maybe you could do an example. Yeah. I was going to show the results of a run, but it's not working.
Can I just use this for the line?
Yeah. Uh-oh, what happened here? Oh, it didn't install right. Oh, library problem. Okay. Never mind. I won't do that. You want to do the Hector mine? You want to run that one? Here?
Did you want me to?
You could.
I mean,
yeah, you could.
That's what was on the.
I was trying to get it to run, but it didn't have GMTSAR here, and I ran it. I installed it with Homebrew, and it just crashed. So, why did it crash? And we could use another computer. That'll work. That's right. You're up at 2, right?
Huh?
Are you up at 2 o'clock? I can't remember the schedule.
2 o'clock.
Okay.
So yeah, I was just gonna go that same PowerPoint from last year. That's
Okay.
go through that and then
Show some of the output.
yeah, we can do go to our like side hub.
This thing is not working. Control F. Live Pro.
I don't have access to SSA.
No one's no one Yeah, I mean, yeah.
Processing.
But no capability. But now we have it.
Hmm.
Yeah, but the data.
Oh, okay. Hmm.
Yeah.
Never had anything installed. But I don't know how to start the web thing.
Did you get the link from?
I could get it, I guess. Let me.
It's on the email from Melissa.
I just didn't want to take my computer and put it over here because then I can't do email or anything. Yeah. But I guess I'll have to.
Yeah.
Okay, can the remote people hear me? Anybody want to speak up? Jay won the topo contest, but C1 came in a close second. That was the Australian topo, and I didn't really want to mail this cup to Australia, so I don't know if they want. Here's the cup. SIM. Okay, so everything's running. Scott's going to go over how to access data. And maybe we could do a real-time thing accessing some Sentinel data from the Sentinel Data Hub. And then we'll look at some of the output of the InSAR just to make you familiar with what all the different files are, directories and that kind of thing.
Perfect. Okay, so I'm going to talk a little bit about the different SAR data archives and the various satellites. So we'll go overview of the satellite SAR missions and then show you where the different data are available. And then we'll do some searching and downloading. So this is a diagram of all the available satellite SAR missions. So we have C-band, L-band, and X-band SAR missions. So from 1992 was ERS-1, ERS-2. We had JERS in 92 as well, so that was a L-band. And then, yeah, the first X-band satellites that went up were in Cosmos SkyMed and TerraStar X in 2007. So over on the right, we have different missions, the time that they were active, and their repeat frequency. So ERS, NVSAT, those had 35-day repeat. ERS, they had a mission, a 3-day repeat ice phase. So they reconfigured the orbit of the satellite for like a year or two. And then ERS-2, the last 6 months was also operating in this 3-day phase mode. So they didn't get global coverage, but you got this 3-day repeat. So when they were looking at ice, you could start getting these kind of ice velocities easier. So then the X-band satellites also tend to be higher resolution. So the C-band, we have maybe 20 meter pixels, L-band the same, and then the X-band, anywhere from 3 meters is the standard strip map mode, and then they have a, 25 centimeter, I think, staring spotlight mode. So you can get some very high resolution SAR imagery. And yeah, so the new NASA mission, InSAR, it'll be an L-band mission. It's supposed to be launched in 2021, I think. Keeps getting pushed back, but do you know if they were talking about having it just be a left-looking only, because they had this period where they were going to do left-looking, and it was going to be mostly right-looking. All these other SAR satellites are right-looking. So I think they made the decision, and I'm not sure if it's finalized, but it's going to be all left-looking. So you'll get this other viewing geometry at L-band. If you wanted to try to do 3-dimensional, yeah, you need that kind of left-looking ascending, descending path. So now you can do like true 3-dimensional displacements. And yeah, so all this information is available in the CEOS database. There's a link down there at the bottom. You can go and see all the SAR and all satellites actually. So at UNAVCO and the WinSAR, this is a footprint. So most of the data from UNAVCO will be focused on the Western US. We have ERS, NVSAT, RadarSat-1, and then we're also archiving and managing proposals from community members. So we have TerraStar X, ALOS-2, and Cosmos SkyMed data from that. So all the data that we have are raw, so level 0. SLCs from TerraStar X and ALOS-2, just because that's what they're delivering space agencies. And we kind of have all these organized into different collections. So you can do a search, we'll do a search later and show how you can find which ones you have access to. And then we also have SuperSites data. If you're not familiar with SuperSites, it's a group on Earth observation, GEO. It's an EU initiative. And they've defined these sites around the world for earthquake and volcanic hazards. So Kilauea, San Andreas Fault, and then, Italian volcanoes, and some other ones. So the idea was that all the space agencies would be providing all of the data for covering these super site areas free of charge. So you can go in and actually get the data over those limited areas, and it's free and open. The DLR German Space Agency. For TerraSAR-X, they have their own dedicated site where you can go in and see all the different super sites and all the data available there. You just have to register for an account. And then this EO Virtual Archive 4, you can see a lot of data over Asia and Europe. So that's all data from the EO Virtual Archive 4. And that's just, it's mostly ERS and NVSAT data because it's ESA. The Alaska Satellite Facility is the other kind of big archive that has free SAR data available. So they were the data node for North America for ALOS 1. So all the ALOS 1 data that was acquired over North and South America is actually archived at ASF. And I think now those data sets are open, so you just have to register for an account and agree to the license. They do have coverage that extends outside of North America. So while all the North and South American ALOS 1 data was going there, but they also have data from outside North and South America as well, but it's not the complete archive. All the RadarSat 1 data was actually archived at ASF, and all the data we have at UNAVCO we actually got from ASF, so there's kind of two places that you can get that data from. And they are operating a mirror of the Sentinel-1 Sci-Hub archive, so all the Sentinel-1 data is available from ASF. It's just a lot of times there'll be a delay, so it'll show up on Sci-Hub, and then some time later it makes its way to ASF and into their archive. So yeah, the Sci-Hub, this is where they're distributing all Sentinel data, not just Sentinel-1, but Sentinel-2 and Sentinel-3. And originally they said it was going to be a rolling archive, so it was going to only have like 3 months of data in there, but I think they've changed their mind now. So the entire Sentinel archive is available at Sci-Hub.
So you need to get an account at ASF, do you need to be a US citizen or something like that?
No, it's just the Earth data login. So
to get an Earth data thing, do you have to be in the US?
I don't think so.
Anyway.
I don't know.
ASF? Okay. Because the ASF one is a lot faster than the Sentinel data hub.
Yeah.
But it doesn't have the newest data.
Right. So yeah. And yeah. Yeah. And then ESA also has this on-the-fly service. So any of the ERS or NVSAT data, you can go in and request SLC data free of charge through the EOLESA interface. In the last couple of years, there's been more and more interest in actual interferogram data products, and ASF has their Getting Ready for NISAR Griffin data set. So they've been producing kind of standard data product InSAR images, I think from Sentinel-1. So you can go in and find already made interferograms that you could use for modeling or stack processing, time series processing. Comet also has their interferogram archive. I think most of their data is kind of focused on Asia and the Andes. So it's kind of the areas that they're interested in and have projects going on. So they're producing and sharing interferograms there. And then we also have the InSAR community contributed archive. So you can upload your archive, your interferograms to the archive there, and they'll be shared. We don't have a whole lot because not a lot of people are kind of routinely processing and uploading them. But yeah, in terms of access, so each and every one of these sites has their own special login. So you'll have to go in and get all these different logins from all these places if you want data from them. So for UNAVCO, you can sign up for an account through the InSAR portal, and ASF, yeah, I guess this is their Oh, what's this? I don't know if they. Well, it's exit. Yeah, I guess we could see. Yeah, I don't think there's any restriction in terms of. So yeah, you have to register for this Earth data login and then go into the ASF site and get approved for those for that data. And yeah, so the super sites is the same. You got to get one for the virtual archive 4 and then one for the DLR. Sci-Hub, you can register on the Sci-Hub site, and they have restrictions on the number. You can only download 2 in parallel at a time from Sci-Hub. So, I mean, that's one of the reasons it's slow. If you got 100 images, you know, some of these areas in the world now we have close to 100. You know. So yeah, it takes quite a long time to download it. But like we were saying, it shows up there first. So if you need the data, you can go get it from there. And
Does the ASF require that you have to submit a proposal before registering?
no, that was just for their ERS, JRS, and RadarSat-1 data. And I'm not sure if it. Yeah. Yeah. And yeah, this is just an overview. So let's see if we can.
We do a search.
Yeah.
The data, either ASF or the Open Data Hub, either one.
Yeah.
That one's easier to get to.
Yeah. So this is the Sci-Hub. There you go. So what, somebody wanted Utah?
Utah. We're in Utah, everyone. Canyonlands. Now, since you can only get 2, you know, the time interval.
Yeah, I want as big as possible. I was looking at it right now, and I think I want the earliest 2015 and the latest 2015.
Yeah, but you're not going to, it's going to give you everything in between.
That's fine.
Okay. It'll be like 100. You can only download 2.
Oh, okay, I see. Well, I can you just get the first or last.
You could make a time interval just for the last, and then make a time interval just for the first. And you probably don't want the first one because the satellite wasn't, it has some kind of antenna pattern issue. Eric might know when that ended. You can fix it, but it's better to start. When is that antenna elevation pattern? February 2000. Oh, okay.
So if you're downloading data like now, probably you already have an idea of what that is later than so you shouldn't have that problem. But
Just get the most recent one, for example. Just get one, you don't want to get.
So you can select which modes you want. And then search.
You got all the dates.
Hey, I have a question.
Yeah. But yeah, you can just filter it down more if you want.
Like the last one.
Hello.
mentioning that can download from that site.
you should probably install one of the meta file downloaders. Because if you download everything that's in your cart, it comes down as a meta file, and you have to have something like area 2 or similar to download.
Okay.
Files.
So the other decision you have to make is, since to do interferometry, you always have to have the same track. So you click around and you figure out what track that is. Like, is it 84? And then we can set 84 over here in the search and just get that track.
Yeah.
I don't know
So
what
for
track
the go to GitHub. Yeah.
click on it, we'll say what track it is.
Oh yeah. So we have our command line utility. This is a little Python, and it'll search ASF and NAVCO archives. So you can do a parameterized search here. And there's also a web GUI. So this is kind of the API, similar to Sci-Hub, but this will now give you results for ASF and NAVCO and the super sites. So we archive the data or the metadata. So you can just select a box here, same thing. You can put in start and end times. So you can see that it's just Sentinel-1 data from ASF. So this gives you the track and the frame. So this relative orbit. So you can do relative orbit 93 and 173. So you would want to pick,
But the frames
93. Yeah, the frames are, well, so ASF made up these numbers.
Oh, really?
And I noticed that their ALOS data, they redid their frames. Okay. So like instead of a frame 3900, it's 3902. So you can't do, they messed that up. Right.
So if you go to the Sentinel Data Hub, let's just go back here. Like click on, let's say you wanted data from that area that has 2 frames, because that happens all the time.
Yep.
So you draw your box so it just is inside of those 2. And then you figure out what track it's on. And then you have to download 2 for every time, every acquisition. Yep. And then you have to stitch them together. And that's we can go through that later.
Yeah.
Because the area you're interested in is always on a frame boundary.
Oh yeah. Yeah, and this is, when you click on these, you can actually.
Yeah, if you click on the little eyeball here.
Yeah.
You get. Tell you what, this is the relative orbit number down here somewhere.
Yeah. Oops.
It's orbit number 129. So then on, you only search for 129, and you won't get all that other stuff. You just get the one.
Yeah, you can come back over here and just say.
Put 129. Yeah. And then do another search. And then if you made your box really small, you would just get these 2.
Yeah.
And or maybe just 1 you're interested in. Yeah. And then you have, it came back with, oh, it's just SLC. So how, that must have been several repeats.
Yeah.
There's 6 products, so there's 3 repeats in there. But you can only download 2 at a time.
Right. So you could, we could do the same over here. And again, so relative orbit 129. Yep.
Those are the 6 products.
Yeah.
And then once you figure out what track you want and the box, then you can use it in Scott's script. So just every week, go and get some new data.
Yeah. So with this command line client, you can just run it.
You don't have to do this anymore.
Oops. So the command line client, you can put in these platform orbits, all the different, you can have a WKT, well-known text formatted point, line, or polygon. So you can do some, you can actually put multi-points in there. So you could have, you know, little, like if you wanted all the volcanoes, you can just have a multi-point representation of all the volcanoes that you're interested in and do one search. Right, so you want to have the same relative orbit, the same beam mode, and the same beam swath in order to do interferometry. So here you can set up and do a search and find, you know, exactly what you want. And yeah, for this DEM option now, when you do a search, it'll, let me do this. So the default is just, it returns 1,000 scenes from each archive. So you'll see 2,000 here. You can do print, and it'll print out a list of what was found. So you can see track frame. So if we say -R87, so that's the relative orbit. So it found 244 scenes over Kilauea for track 87. Yeah, if you do this --DEM, so it'll do the search, it'll find all the scenes, and then it actually downloads the DEM that covers all of the scenes. So this is actually going to OpenTopo and downloading. I think I used GDAL. So we have this virtual raster with all the data already converted to ellipsoidal height. So you can just go in and give it north, south, east, west bounds and get any DEM. So that's going to take a while just because it's probably a large area. And there's no limitation on the area.
Yeah.
So you can download the entire archive. Yeah, any questions?
So you have a list of the platform names in there. So it says which platform you want. I guess I'm only writing this spelling thing.
Yeah, I mean, that would be a good idea, but I mean, usually what I do is I'll just do a, you know,
Search for everything.
yeah.
Well, yeah, I'll try to. Maybe on underscore two, it's supposed to be those two.
Yeah. So if you go, oops. If you go to the GUI,
So yeah, I really like, it says platform. I don't know what type of platform I'm guessing what I'm supposed to type.
yeah, so usually,
/2 or /2 or
yeah.
_2 or something like that. So
I usually will just start with an area. And then you, yeah, so you do a broad search and then you can start narrowing it down. Yeah.
So one thing, let's look at this. This output here, some of these are completely open, but some require passwords. So if you go to download, say that CSK, it's going to say, give me the password.
Mm-hmm.
And every one could have a different password because people have been writing proposals to Cosmos SkyMed, ParaSAR-X, and ERS is open now, but
yeah.
But with Sentinel, you don't have to do any of that.
Right.
It's just wide open.
Yeah. So yeah, these also call it Cosmos SkyMed and TerraSAR-X. Basically, they, because the satellites can't acquire that much data, they're only acquired via tasking. So Sentinel's just, and ALOS 2, they kind of have these basic observation scenarios where they're going to get global coverage of everything. But for some of these other, you know, commercial satellites, yeah, you basically task it. So chances are, if it's a active area, somebody else is probably getting the data, but if it's not, then you have to start tasking. Or just use Sentinel. Yeah. Yeah, and it was always this, we were talking about putting like the list of the platforms, but then that becomes a perpetual maintenance. Every time a new one comes in, you have to put in, you know, go and update your software to do it. So.
Sentinel is the one that is available in Sci-Hub and from the Alaska website.
Yeah. So yeah, I would you know, download it with Cicera first, and then, you know, if there's a scene that you know is not available from ASF, then you can go grab that one or two scenes from Sci-Hub. Like the latest earthquake, there was I went on the day that it was acquired, and it was at Sci-Hub, but then it just never showed up at ASF. So I had my little seamless SAR archive script that I just ran, and if you run it over and over again, it will just get download the new data. So smart like that.
One of the other things is that with some satellites, when you download the data, you also get the orbit data.
Right.
ALOS.
Oh, right. So
But with Sentinel, you don't.
Yeah. So, and again, on the command line client, there's this S1 orbits. So if you just say dash S1 orbits, it'll also go and get those. It'll either get the restituted or the precise, whichever one's available.
So the best is the precise orbits, but they're not available until
21 days.
21 days afterwards. So if you want to get something from earthquake, whatever, yesterday, then you do the red zone, what they call red zone. That's right. That's right.
Yeah, the restituted.
Yeah, and they're pretty good.
Yeah, I don't think there's that much difference.
Yeah.
And now they're providing all the GNSS, the onboard GNSS data, so you can make your own, you know, process the GNSS data, make your own positions.
Really?
Yeah, so they put the GNSS data in Rhinex files, I think it's like 1 week after acquisition, or it's like a week delay. So in theory, you could have even better orbits sooner than waiting for the, if you really need it. But yeah, I think for the most part, the restituted orbits are fine. Yeah, so.
So maybe later on we could do an example, just two Sentinel scenes and two orbits, getting that.
Oh, I mean, we could run this here. They can specify a start and end time. So I just say dash S to start. So that's 5 scenes. Yep, 2 scenes. So if you say DEM and, oh, I don't have, So there's a password config file in here. Oops. So you can put your password, username and password for ASF and UNAVCO and SuperSites. And then when you run the command line client, it reads that out of there. So if we run.
You cannot download the frame from the GUI still, right? You can. Oh, you can?
Yeah, you can download it. But I mean, if you're processing on your laptop, it's fine. But I don't ever process data on my laptop, so I'm always on a server SSH'd in. So this is an easier way to get the data over there onto the server. I mean, that's.
So how you get it, like using Perl or something?
So this has little downloaders in there.
But that's a URL, right? Potentially you could.
Yeah, you can just click on these. So this just uses that URL. So if we say DM and --S1 orbits. There. I canceled the DM download. Yeah, so you could just use this just to download the orbits. So if you already have your data, you can just run this again and it'll go and grab all the orbits for that. Okay. Any questions? So now we want to do the Hector mine example.
Go to the desktop and there's a directory called InSAR.
Oh, is it already in there?
It's in. Oh, did you have a PowerPoint or something or not? It's going to look in the directory. Okay. So the InSAR, go to NVSAT, Baja, EQ. I did NVSAT.
Oh, okay. Okay. So all of these examples, we just have the one command, P2P.
Yeah. So we changed it. Now there's no more P2P NV. Well, there is, but this is the new one here where you put NV here. And you don't need the config file as a default one. So you can run that. If you run that, that'll wipe out everything and it just ran. So that's okay.
You just want to go through what it's actually doing, or?
We could let it run, but it'll take 5 or 10 minutes.
Yeah. Well, if you've already got it, we can.
Yeah, I just ran it a minute ago. So you would run that. So every one of those download examples has a README, and in the README it says this is how you run that example, and then when you want to do your own thing, you have to just set it up the way this is set up. So,
yeah. So this config.mv.txt, normally you have to have that, but if you use this P2P _ processing, it generates that automatically for you.
I don't know if you want to run it or wipe it out.
Okay. So there's the raw directory that has the raw data, and then
The orbits.
Yeah, the orbits. So and when you run it, it creates this SLC directory, and then in there it'll focus the two scenes, and then it does the cross correlation and registers the repeat image to the reference image, and then it refocuses with the offset parameters. And then you have a co-registered pair of SLCs. You have the topo folder where you have the dem.grd, and then you have the master reference PRM file, and it generates this topo range azimuth. So this is now the topo in range azimuth coordinates, and also this trans.dat, which is just range azimuth, lat long, and elevation. Oh, is it? Yep. It is. Okay. So yeah, with those done, then the interferogram creates this INTIF.
I don't have LL.
Well, it comes on default in Cintas, so yeah. So it creates, when you mix the interferogram, it creates the folder with the year and then the Julian day. So if we go into there, they each have AMP1, AMP2. So those are the amplitude images of the SLCs, right? Yeah, and then, well, it looks like it didn't complete. Yeah, it looked like it failed. Because you have, so you'll have a phase.grd and a phase filter.grd. And you'll have a core.grd. So it must have failed somewhere. Oh, okay. So there's nothing to look at.
Yeah.
But, all right.
Okay. But on Friday, you'll have all your examples. So.
All right.
Thanks. Any questions about that? Yeah, maybe we should do a data search example later on.
Yeah, there's some little details in there, like you get a list, like if you go to Alaska, for example, you often get choices L0, L1, L1.1, and all that. It's good to know which one to pick. There's all sorts of little logic in the process.
Yeah, failed. Failed the same way on that computer. Weird. Well, these guys ran it, so maybe I could show it on your computer. Oh, but then it wouldn't run the web thing. Video chat. I don't have an example that's run here. And you guys have it, right? Maybe I'll show it. I can start the video chat because I think it's useful to go through that whole thing. Okay, so I'm okay. Okay, so yeah, the one that Scott had didn't finish correctly, so I thought, well, let's go through a completed run. So this is a little bit more complicated. This is Sentinel-1 acquisition, and Sentinel-1 is a GMTSAR, so it has 3 subswaths. So it has to make 3 sets of interferograms, and then it combines them all into a merge directory later on. So again, you start with the raw data. I'll make this bigger. Should I make it bigger? It's getting all the dot. LS must be LS minus A. Anyways. AF, okay. So you see in this directory, there's 4 files. There's 2 .safe. Those are actually directories. That's what you download from the Alaska site or from the Sentinel Data Hub. They'll be zipped up. You have to unzip them and you put them in here. Then you have to get these 2 orbit files that match the 2 data files, and you match them by the date. It's this, and it's very confusing here because there's 3 dates, and the first date you ignore. That's the day that the data were processed. But the second 2 dates are the date span, and you want to make sure your InSAR image is between those 2 dates. If you run Scott's thing, it'll do all that for you, but I'm just showing you what has to be set up there. You should do this once, so you sort of understand that you need 2 files, 2 save files and 2 EOF files. And then in the topo directory, you just need that dem.grd, the same one that you use to make the exercise, dem.grd. And then in this case, there's a README. And the README This is a pretty short README, and it just says, this is what you need to do you have to get the data, and that's something different. And here's the processing, P2P. Oh, this is
That's the high res.
the high res.
The first time I just ran the very top one.
Okay.
Generated F1, F2, and F3.
Yep. So you give it this tops frame, and you give it the name of the safe file, which is this horrible name. Your eyes go crazy looking at these things. And then you give it the name of the orbit file, .eof, and then you give it the name of the repeat safe file, give it the name of the repeat orbit file, and then this config file, which tells you how to do the processing. And the first time you run this, it'll create a config file that's a default, but you might want to change the parameters in there. And so let's go through that config file, because for Sentinel, it's a little different, and it's sort of important that you do a couple things the right way. So inside of this config file is, the first part is it says, where do you want to start your processing? Right from the beginning, do you want to start at step 2, step 3, step 4? And the reason for this is maybe you'll process it the first time and not unwrap the phase, because you don't know if it's going to be any good or not. So you'll just go up to, later on you can see where we'll set the phase unwrapping to go on or off. You could also skip a stage. If you mess up, but you know that when you made your topographic phase, it was okay, you could skip number 3 and it will run a lot faster. If your topographic phase is screwed up, everything's going to be screwed up beyond that stage anyway. So I like to start off fresh, but if you're really confident that you did it correctly, you can skip that. Or later on, when you're doing batch processing, you'll do all the alignment in one step, and then you'll do the topo phase, and then you'll do all the interferograms in a third step. So you'll have to just understand you're doing, these in sequence like that. If these things are blank, it means that you don't need them. These are relic things from ERS and NVSAT and so on, Doppler centroids. We don't worry about that anymore because the Dopplers are so well controlled on these satellites. We don't need to shift the image to match the topography anymore. It's perfect because the orbits are really good. So it's a lot of relic stuff in there. Here's something that's sort of important. We're going to process 3 subplots independently. And if you put in, later on we'll put in a filter, you put in a filter wavelength. I want to filter it at 160 meter wavelength. Since each subswath has a slightly different range in azimuth sampling, it may design a filter that decimates not always the same for each of the subswaths. So you can override that here with this range decimation of 8, azimuth decimation of 2. You can make those numbers anything you want. You could make them 1 and 1 if you wanted super high resolution. But in order to get these things to merge properly, these numbers have to match up. So run the default case first, and then you can get in there and tune things later on. It's not going to make the ionospheric correction because, as Eric said earlier, this is not, it doesn't always work very well. There's not enough bandwidth on these satellites to make a really good ionospheric correction. We have to wait until InSAR comes to do that. So that's shut off right now. And then this thing about the threshold for snafu. Snafu is a phase unwrapping program. And right now it's set to 0, so it's not going to unwrap the phase. And you want to do that the first time because phase unwrapping could take, it could take a half an hour, but it could take 3 days sometimes. And you don't want to wait 3 days to find out that it's completely garbage interferogram. So you do it once with a 0. And then later on, you can set that threshold to some number like 0.1 or 0.2, whatever you feel comfortable with. Maybe we'll talk about this later, but I'll mention it now. If you have a lot of water in your scene, like ocean or Salton Sea, you don't want the phase unwrapper to unwrap in the water. It takes a long time and it gives you the wrong answer. So there's a thing called near neighbor that helps you unwrap in the water areas, and then you blot them out later.
No, this threshold is Snapple. This is a 0.1, 0.2. What is the basis of that?
That's
What is the threshold correlation?
it's the correlation, and mainly just based on experience. Maybe Eric, what's a good number for phase unwrapping threshold? 0.1. So you can always mask out any phase later on that you're suspicious of. And it will sometimes make phase unwrapping errors that are too pi off.
So when you set it to 0, it doesn't perform phase unwrapping. When you set it to a value, will you repeat what you did before, or you will pick up where it left?
That's where this is important, because just say, I want to start from number 5. And then you don't have to wait for that whole thing to run. Yeah.
One example is that, for example, you want to redo the qualification after you get the pretest part, for example. You need to run step 2, but maybe you don't really want to run step 3. And you can actually see after the skate maybe. If you want one column to be skipped, you can just add a comma and another number, a comma and another number. So it will skip the certain stages you don't want to run.
But you have to be confident that you know what it's doing.
I guess I wouldn't, if you're beginning, I wouldn't overthink that. Just run everything for
Yeah.
a long time, see what happens.
Yeah, exactly. Start from 1.
Don't make it more. Yeah. Start from 1, go to the end, and make it forever. And then after you do a few hundred paragraphs, then you'll get more practice.
Yeah.
2,000.
2000.
Can you re-explain that threshold snafu?
Oh yeah, repeat the question. The question was, can we explain the threshold in snafu? And you know, I don't completely understand what this threshold does. Maybe Eric does, but the snafu threshold.
It's actually that's actually a threshold we use to mask out a certain amount of data. So any data that has a correlation smaller than that threshold will be thrown away before you use the data for unwrapping.
But it's at the end of the unwrapping, or is it at the beginning?
No,
Okay, and it sets them to nan or 0?
no, it doesn't change the phase.
Yeah.
It sets the coherence to be 0.
0 coherence.
Whereas
Okay.
optimization won't really optimize that.
Okay.
How does it do the coherence to the 0? You do phase unwrapping like 2525, and
Yeah.
then after that you do like a threshold difference between the number space. And what do you actually do? In neighboring points?
What does snafu actually do under the hood? How does it? Yeah.
I don't think I really fully understand.
I think it's some sort of weighting, but I mean, the basic idea is that any paragraph, some of the pixels are just going to be bad. Correlation is going to be terrible, and maybe there was trees growing there, and someone bulldozed it, maybe there's water, and you don't want to mess around on that. And so what the 0.12 says, I think it says if the correlation is less than 0.12, it's going to tell snafu to kind of ignore those pixels. Now, how snafu actually ignores them is no one really knows, except maybe Howard and
Chen.
But
Yeah.
that's the basic idea. It says ignore these pixels, we don't think there's any information. And that's typical, for example, if you're trying to do Brazil, for example, and there's a bunch of trees growing, you may have more correlation.
It's a lot of trial and error, I think, that part. And this thing with the nearest, if you have ocean, it's really important that you don't unwrap the phase out in the ocean, because it might try to connect phase from one coastline all the way down to the other coastline and get the wrong answer and put a phase unwrapping boundary in the middle. So there's a way to mask that out and then use this near neighbor thing to ensure that doesn't happen.
I mean, either it works great or it's a lot of work.
Yeah.
Usually the best thing is find the ones that work great
NVSAT, you showed two examples to run P2P processing.
Yeah.
And then there was one that was NVSAT specific.
Yeah.
And the NVSAT specific needed the config file, but not the other one.
I don't think it needs the config file. We just put it in there. The older one did,
Yes,
yeah.
for the older one did, but this one is Sentinel specific. There's no P2P, and then it has Sentinel as an argument.
Exactly. So actually, this calls the P2P processing deeper inside because it's doing 3 subslots. And so this is a higher level thing. Eric knows how these all work, but it's pretty nice because it does, if we're going to look inside these directories, F1, F2, and F3, and inside those we'll see a raw, a topo, an SLC, and an INTF. So it independently processes those 3 subslots and then goes and merges them into a single product. Because sometimes you don't want to have the boundaries.
So before you go to P2P,
Yeah.
we have those frames sitting in the raw. So there is a process to get that data from the. We are going to go through that.
Well, the download. Yeah. Repeat the question. Okay. So the question was to execute this P2P S1 TOPS frame, we need to have the safe files and the EOF files, and we should go through an example, I think, start to end. Yeah. So that's exactly what's going to happen next. Well, yeah, that's a great question. Yeah. Yeah.
I forget the option that you were saying, but underneath it, it says like wet region mask. So could you not just let it mask?
A water mask.
Yeah. You were saying the near, or make that one, but could you just make the water mask one?
So the water mask just goes into GMT. Oh, the question is, why is there a near interp flag and a water mask flag? And there are sort of different things. The water mask flag simply goes in and to GMT, and it does a water mask, and it maps that into the range and azimuth coordinates. It makes those all 0 or nans. And then near neighbor goes into that and says, oh, I got to fill all these nans with the near neighbor of the nearest phase to the coastline. And there's a paper by Piyush and some other people that say, if you do the near neighbor, it runs infinitely faster, but it also gives you the right answer to up and down the coastline. It doesn't force a 2 pi phase change in the land. And so near neighbor is really good for getting an accurate phase unwrapping when there's a lot of water. So, and it runs fast, but near neighbor itself takes a lot of time to run. It can take hours to run. Yeah. The dense. Yeah. The question is, what is this decimation factor? Well, let me go through the range and azimuth ones first. There's 2 decimation factors. One here is 8 in range. The other one is 2 in azimuth. Up here, we said, this is something you sort of have to know. We said we're going to filter this particular interferogram at a wavelength of 160 meters. Now, in order to sample that wavelength properly, you want to get at least a 40-meter sampling, 1/4 of that. And if we go twice in azimuth, you just have to know these numbers off the top of your head. It's about 30 meters sampling. So you've oversampled a little bit in azimuth. And the same thing in range. If we want to get 40 meters of sampling in range, we can downsample the range by a factor of 8. So you have to sort of know these things, and they're built in to these config files. But again, how to?
Signal 1 has 5-meter range, 15, 20 meters.
Yeah.
You do the math.
Do the math.
You want it to be almost square pixels, so it's like 8, 40, 2 is 40.
40 meters. Sentinel's unique in that the range is higher resolution and has all the other satellites will have 5 meters and have 20 meters. So you'll see those numbers reverse.
So there are like two estimation methods you see there. Actually, if you don't classify avenues DC or DC, just leave them open. They will compute one for you based on the DC factor, whether it's 1 or 2, 4 or whatever. But for tops, it's kind of required that you specify the range and avenues, because when you are computing based on estimation factor and filter wavelengths, it's going to be slightly different for the 3 subplots because of the load pattern. The range pixel size changes from near range to far range. When you have such wide swath, the further away you get from the near range, the larger pixel range you get. So the estimation will change based on these 2 parameters. So you want to force it to be the same for all 3 subplots. But later on, when you're trying to put everything together into one outlet, it will be easy.
Yeah. The other satellites, you don't have to do that. Just GMTSAR. ALOS too. Yeah. Okay, so each of you should try one of these Sentinel things, and but let me walk you through the rest of the file structure, just so you have an idea of what we're seeing here. If we were doing NVSAT, we would just have the raw and the topo and the config to start with, and it would create an SLC where it would put the aligned SLCs, and it would create an INTF directory where it puts all the products. But because there are 3 subswats in Sentinel, F1, F2, F3, it does that 3 times. So let's go into F1.
Yeah, so Sentinel is scanning instead of scanning radar, and that's why it creates 3. So it's downloaded 1 file, but when it images it, it actually makes these 3 scripts.
Yeah.
So when downloaded, when you went there and you look at a say Don's thing and you download one nice square, but because it's a GMTSAR, it's actually broken up into these 3 separate images. Radar with dig, 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 like that. And that's what the F3, F1, and F2 are. And so, for example, this one, the earthquake is over here in F2 and F3, and I was really disappointed. I looked at F1, I saw nothing. I was like, oh. But then it was like Christmas, I looked at F2, and there was an earthquake there.
So the processing gets done in 3 steps, and then it gets merged later on. So let's go into this. We'll see a raw, and we'll see a topo, and these are just copied from the higher level directories, basically. But let's, in the SLC, don't worry about that. But the INTF is the one where we should go in and look around a little bit. So it, again, it has these 2 dates. These are the year and the Julian day. And then it has all these products here. And I'll walk you through these things. Amplitude is just the backscatter amplitude. 1 and 2 would be the reference and the repeat. Correlation is the coherence or correlation. And there's 3 files here. There's a CPT file that you would need for GMT. There's a grid file, and then there's a PostScript file. This one didn't run either to the end. Oh, I see. They're in the merge directory. Never mind. Okay. And these are all in radar coordinates still. And then there's a phase CPT and a phase GRD and a phase PS. And filtered phase, this is filtered in a slightly different way. And I thought there would be PDF files in here, but I don't know what happened.
Yeah, I don't know. I read it yesterday.
Let's look at some of these. So we're going to look at F1 and be disappointed because there's no earthquake. There it is. Yeah, no earthquake. There's something going on there, but oh, and that did some weird thing here. Huh. There's the amplitude, and here's the coherence. It's very high. This is Barstow, and you see these little round things are crop circled where the irrigation is going on. So F1 is sort of boring.
And then at the very left side, you see SLC, that's the image. The LED is what's called a meter file. It has, and PRM is metadata, should be ASCII metadata that has function parameters for these processes.
Oh, I know what happened here. Okay, never mind. This probably didn't run to the end either. Yeah. Yeah. Okay. Where are we now? F2, we'll see an earthquake. I bet the merge thing didn't work on this one. So there's the earthquake. It's really nice. It's in radar coordinates. Yeah. Was this GMT6?
I think it's not even 5.
5?
I'm not sure.
Okay.
That says everything.
All right. And we're gonna be disappointed because there's not gonna be anything in the merge, I think. Oh, it's okay. Well, it doesn't have the KML files. So there'll be a phase file, a coherence file, and an amplitude file. And there's the phase of all three put together. And now you can see the three subswaths they start at slightly different times. So there's the descending. That's number 1, number 2, number 3, and they're all merged together into one file. Yeah, they match perfectly without any adjustments. Or this radar is really super. Here's the coherence. And what you see is low coherence, like when there's a lake, because the water doesn't retain, it's moving all the time, so it doesn't retain any phase coherence. But you also see low coherence where the ground has shaken all the rocks and they moved around, and so this is the earthquake here, and you can see the high shaking areas. There's the conjugate fault. Trona is here where they had a lot of liquefaction.
Looking, you can also see areas with landslides that were triggered.
Landslides in the Sierras, mostly, or?
Mostly, if you go up north to where you have the volcanic.
Oh, up here. Maybe it's the next frame.
It's in.
Probably over here. Where it's steep over here somewhere. And I don't think the KML worked. I don't know why. What's that? And I forgot the syntax. So you give it, yeah. Phase filled LL and the CPT and phase dot CPT. Turning.
Oh, I bet Image Magic isn't installed like that. It might have had issues making the PNG file.
Yeah.
I think it was Image Magic.
Image Magic.
I don't have it installed.
Oh, it worked. Do you have Google Earth?
No.
Oh, well. You can see it in Google Earth. If you had Google Earth, and you can zoom in and yeah. Okay. Okay, why don't we take another break, a short break. It's tea time. And then we can come back and do a little bit of theory and work on the projects. Has everybody run at least one of the test cases? Have they all figures work?
Yeah, it does it. Returns to a I have the actual. Oh, the actual. Unless there's one running Sentinel. I'm running Sentinel, but I'm not getting any results. Nothing. It's not speedy to work on. GMT, that's a good sign. Water on the brake switch. Oh, I only have one quick voice. I only have one quick voice. But it's doing GMT because I can see it. So here there's a project set Oh no, but I have 1 gig free of RAM.
Yeah, it's running kind of by chance. Yeah, I guess he is. He's throwing up right now. So this is running on
Yeah, this is from the this was from the evaluation. Downloaded another of the application example.
Yeah, so there's just you let that off. So all the outputs. Yeah, so it's still making the law. That's the data faculty directory. I just want to make all three of those. I mean, it'll probably take an hour or two. No, it's also there.
Oh, yeah,
Yeah, that's it. You do it. It's processing. Yeah. So this is here you put it on. This is the whole points. I think that's our so you've got entities. So this will automatically create file. This one you have to have. This one you can run and create.
It's handling the same place.
Yeah.
But the file size is not changing. Yeah, that could be.
They're big like usually several kinds of yeah. Oh yeah. We do that every week. So
I know, I'm not right now.
It's going up. It's still on top. Yeah, so he Baker, he has are you Yeah, both So this is just for searching what files are available.
I'm just gonna go through some basics of SAR and InSAR right now. And really basics and talk a little bit about orbits. And then you can go into that's tomorrow.
Yeah.
Okay, does everybody have done their example? At least one example. I think we have one going over here. Hector, I don't know if you got yours finished. It's running? Which one are you running? For what? Is it? Rich guys is a huge one. So maybe, well, let this one run. So in that command, there's a, if you type in that CP frame thing, there's one of the parameters says, do you want to do it in parallel or separate? And if you do it in parallel, it'll lock up your whole computer. And it can take forever to run. Here's running. Running in parallel. Might run it. That's how much time it has. No, there's always been created. You're not going to work. No, I don't think it works. Didn't work. Did it destroy the EM in that folder? You look in the profile. Yeah, we're going to start. Okay, for the online folks, we're going to start in a minute. Do you have any questions about processing data? Have all of you been able to process one of the example data sets, maybe a small one? I see a bunch of people online. I can go to the chat here. Chat. More? Okay, well, so what I want to do in the next, I'll try to just keep it to 30 minutes, is go over some of the really basic SAR and InSAR theory, just so you have an idea of what these instruments are doing. And then tomorrow, Rob will talk about focusing imagery, which is a whole large topic. We'll try to get it down to something very small. And then we'll go into things like ScanSAR and also time series tomorrow. But also keep in mind that on Friday morning, you're going to be presenting stuff to us. So group up in pairs of people, come up with a project that's sort of doable, and we'll have tonight and tomorrow and to work on a project. And then, you'll be entertaining us on Friday morning. We'll have the whole morning to go over these examples. So, and if it's just, I ran the Hector mine earthquake example and here are the results, that's fine. It could range all the way from that all the way to, I did a time series but that's going to be hard on your laptop. You'd have to find a supercomputer to do it. Okay, so what I want to talk about now is just a little bit about the theory, so you get an idea of what a SAR does and what InSAR is doing. And if you go to that website, that topex.ucsd.edu/GMTSAR, there's some documentation there. Uh-oh. How does that work? I have to share. Huh. I'm lost. How did this come up? Anybody know how to get out of this? There were two PowerPoints running. When I make this full screen, it doesn't.
Oh, yeah.
How'd you do it?
It was the other
It
computer.
was the other computer.
It was set up.
We could just, in the morning, we were just showing the slides this way.
Yeah.
That worked. Everybody see that? I guess. Is Matt?
Yes, it is.
Maximize it. Oh, and I should point out that Matt Way just showed up from Rhode Island. So Matt, why don't you introduce yourself? They'll be talking to us tomorrow.
Matt Way, I was a student 10 years ago.
Yeah.
Yeah, so that's I think involving some early problems.
Thanks. Yeah. So in that website, there's some documentation. And in the documentation, the front part says, here's how you use GMTSAR, and the appendices are a little bit about the theory. And if you really want to understand this, you can go through the theory and do some of the homework problems. We won't be doing homework problems here, but if you wanted to really learn it, you could do homework problems. So there are these appendices, and Appendix A is Principles of Synthetic Aperture Radar, some really basics. I'll go through a little bit of that. Appendix B is SAR image formation, and Rob will do a little bit of that tomorrow. And then we'll talk about InSAR, interferometry, and ScanSAR, and TOPS mode, and so on, but just a little bit from each of these chapters. Here's a typical homework set. So by the end of this few minutes, you should be able to sort of answer these questions. One thing about microwaves that I didn't explain very well before, remember we had those windows. We had the window in the optical and we had the window in the microwave. Well, the angular resolution of an antenna depends on the wavelength divided by the size of the antenna. And so if you're in the optical and you have a very short wavelength, you get a really high angular resolution. You can have a 1 meter telescope and see things on the ground that are like 1 meter. But if you go to 10 to the 5 longer wavelength in microwave, the beam width of the antenna is really wide. And so it's very poorly focused. And so a lot of SAR is about building a longer antenna, synthetic aperture. And so there are some homework problems here on what would be the illumination pattern for different types of apertures, just so you understand what these apertures are doing. We'll go through that a little bit. And the second problem here is, what is the ground resolution? So you're looking off to the side, you send out a pulse, and you want to figure out, what can I resolve on the ground? What 2 points, 2 rocks or something, how close can they be before they look like a single point? And that depends on the length of the pulse that you send out. Shorter pulse, you get higher discrimination between those two. And the pulse length is given here, and you get the angle, and you can figure out the ground resolution. It's pretty simple. And then something about how often do you need to pulse your radar in order to get a full aperture. And there's some basic physics you can go through where you have to pulse faster than a certain rate to get a good image. And that's going to provide some limitations on your imaging of the ground. So again, we had amplitude and phase. First, we'll talk a little bit about the amplitude. How do you make a really high resolution image like this when you're in microwaves and you've got an inherently low resolution system? I should probably just skip through this part, but if you really want to know how a SAR works, you have to do this homework problem here. And it's really not a difficult problem. Here, I'll try to sketch it out for you. This is like your SAR antenna length L. And you take some coherent light, and these are walls that don't allow the light to go through. And this coherent light passes through this slit of length L, and you have some screen very far away on the Earth, and you want to calculate what is the antenna, what's the projection pattern on that screen. It's not just 0 and then 1, but it's going to be this sync function. And you can go through this little bit of math and calculate that it's got this sine x over x projection pattern. And the width of this, I already told you this, is related to the wavelength of the light divided by the length of the antenna. And so if you put some numbers in, I think that's the next slide, you do it in optical, you do it in radar, you get very discouraging numbers when you look at the radar case. So here we are out in space. We have our optical telescope, and it's it's about 800 kilometers from the surface of the Earth, and it has an angular resolution of lambda over L. That's theta sub r here. And you can calculate what size, what diameter spot on the ground you can resolve using that physics. And so the diameter of that will be 2 times h times sine theta r. Put some numbers in. The optical, if you had a 1 meter telescope and a wavelength of 0.5 micrometers, you get a spot on the ground you can resolve a little less than a meter. Pretty cool, pretty good, you know, that's nice. Google Earth type imagery. But if you go to the microwave and you build an antenna that's even longer to try to do better, 10 meters, but your wavelength is much, much longer than the optical. It's a quarter of a meter, for example. Your spot on the ground is 46 kilometers. It's really gigantic. And it's hard to imagine how you're going to see anything. So the trick here is to make this number 1,000 times bigger. And so that's the trick of synthetic aperture radar. So what you do is you send out thousands of pulses per second. These sweep across swath and return back to the radar. And you get the range resolution by sorting these things in time. And then each pulse you're going to move along the track a little bit so you can get the azimuth resolution. But I just told you that was 46 kilometers. It's horrible. So you gotta do something to fix that. The two coordinates are range and azimuth. So in all of our processing, we'll have 2 files. One's in the natural range azimuth coordinates of the radar. The other one is in the lat-long coordinates that you projected back into. Okay, another little math problem. If you had an antenna of length L and width W, so normally these SAR antennas are very long in the flight direction, but they're very narrow or narrowish in the other direction. And that creates a projection pattern on the ground that looks like this, an ellipse. And this can be really wide. This might be 70 or 100 kilometers wide. And that's good because you want to illuminate this whole swath. But in this direction, it's like 40 kilometers. So this is a typical rectangular SAR antenna, and that's its projection pattern on the ground. This is what it looks like as it goes along the track. Okay, so to answer that first homework problem, which is sort of trivial, what's the what's the ground resolution given a certain pulse length of your radar? And it's just a geometry problem. It's about equal to the pulse length times the speed of light divided by 2 or something like that. That's the back of the envelope. There's actually a sine theta r thing in here. So you can build pretty high range resolution by just making this pulse pretty short. The shorter you make the pulse, the better ground resolution you get. And it turns out that the pulse, 1 over the pulse length is the bandwidth. And so when people talk about radars, if they have a very high bandwidth, you can get very good range resolution. Low bandwidth, you get poor range resolution. And Sentinel can resolve about 5 meters in range. ALOS 2, ScanSAR, I don't know, it's like 20 meters or something like that, 30. Pretty low bandwidth. InSAR is going to be some super high bandwidth, 80 megahertz or something. So that's the range resolution. We got that covered. You see that this equation doesn't depend on how high you are out in space. You could be in an aircraft, or you could be 800 kilometers out in space, still have the same range resolution. It just depends on the pulse length of the radar. So how do we deal with the other resolution, the one in the along track direction? Well, this is sort of magical here, so look closely. So what we do is, if we had our antenna here, and it's sending out a pulse, it will have a certain beam width. I said that's like 40 kilometers long. And so what you do is let's say you want to resolve this point on the ground, you start imaging that point from this point, from the antenna here, it's flying that way. You send out a pulse, you get a little bit of energy back from that, you do it again, you do it again, you do it again, thousands of times, and you build up this very long aperture. It turns out the length of that aperture is the same as this beam width of your antenna. So you go through this little bit of math and you find that this resolution is equal to the length of the antenna divided by 2. Seems sort of weird, you know, it doesn't depend on wavelength, doesn't depend on height of the satellite, seems sort of magical. If you're interested, you should go through this little bit of math and you know, show yourself that this is really the way it works. So a 10-meter long antenna can have a 5-meter long track resolution. Sort of cool. Then you ask the question, well, why don't we make the antenna shorter? If we made it 1 meter, we could get half-meter resolution. So why do they make this antenna 10 meters long? That's a big thing to put in space. Here's the clock over there. Is that 30 feet? 10 meters? Yeah. About 10 meters. That's a big, giant antenna. So there's one more thing that you have to consider that is annoying for scientists and engineers. So in order to resolve something along the azimuth, it turns out you have to pulse more often than half an antenna length. So the antenna moves 1 antenna length, 1/2 an antenna length, you have to pulse again. Half an antenna length, you pulse again. Half an antenna length, you pulse again. You get a full resolution image. If you don't pulse that often, you're not going to get a good image. You can't do interferometry, for example. So with a 10-meter antenna, you got to pulse every 5 meters in space. And you can come up with the pulse repetition frequency, how often you have to pulse. And you get pretty big numbers. I don't have the numbers here in the next one. But you find that the pulse repetition frequency has to be bigger than twice the spacecraft velocity over the length of the antenna. That's like L/2. So that turns out to be maybe 1,500 times a second. Typical PRF for a radar. Fine, pulse that often. But here's the real problem. When you pulse, you have to wait until that pulse sweeps from the near range off to the far range before you can pulse again, or the two will overlap in time. So this pulse repetition frequency has to be less than a function of the swath width. If you make the swath really narrow, you could pulse real often. If you make the swath really wide, you can't pulse that often. So this is the real problem here. You got to wait. You got to wait for that pulse to sweep across. And in a standard synthetic aperture radar, a swath mode radar, you can only get this width to be about 70 kilometers. That's all you can get. Unless you build a 20-meter antenna, but the spacecraft engineers won't let you put a 20-meter antenna on it. So you're sort of stuck with this 10 meters. So this is the typical swath mode restriction here. You have to pulse, you have to wait, but you have to pulse more often than V over 2, 2V over L. And in this spacecraft velocity is just dictated by the orbit. You can't, it's always the same. It's about 7,000 meters a second. So anyways, these are the bounds you have to live in. Now to overcome, we want to have a swath width that's 350 kilometers wide, right? So we can get our big earthquakes. So we have to do this ScanSAR that we'll talk about tomorrow. We do one little subswath, and then we do another subswath, and then we do another subswath, come back, do it again and create the bigger image. But that, it creates processing issues for us. We got 3 swaths to deal with instead of 1, that kind of thing. Okay, so that's, if you went through this in real detail, you could answer these questions. This question about the moon, the issue of, like, if you had a satellite in orbit around the moon, it's going slower. So you don't have to pulse so often, so you can do better. Same equations. Okay. So that's, I just want to talk about one more thing, and then I'm going to lose my voice. And that's about orbits. Orbits are pretty important for this whole thing. And then Rob's going to talk about what the SAR processor does. It's got to take all those echoes and make sense out of them. So I think in the last 2 decades, the most important thing that's happened in InSAR, well, one of the most important is that the orbits are really good now. We know, oh, I can't do that. We know the position of the satellite to an accuracy, usually 10 centimeters or better. That's like that much. It's going at 7,000 meters a second. We know where it is to 10 centimeters. And that's really important for all of what we're doing because it makes our processing a lot easier. We don't have to fiddle with parameters like orbit parameters and so on. So about this orbit, well, you need the orbit for 4 things. To focus that image that we'll talk about tomorrow, you're going to need to know the satellite velocity very accurately and the position of the satellite. So you need the orbit to focus it. And to go from range and azimuth coordinates to geographic coordinates, if you know the orbit really accuracy, you can do that transformation very accurately, and you won't have to fiddle with the images. In the old days, they would take the images and move them around on the Earth until things fit. But nowadays it fits perfectly. Another really important thing for Sentinel is that in the old days we used to take, and you'll see this in GMTSAR, if you go back to the Hector DRS, the MDSAT, it'll take the reference image, it'll focus the reference image, focus the repeat image, and then do a cross-correlation of little patches of images, find a rubber sheeting that will rubber sheet the repeat image onto the reference image so they match to a fraction of a pixel. Now we don't have to do that anymore. It's wonderful. We don't have to, we just select the master, I think I said this before, and we use its orbit and the slave's orbit to do that image alignment, and it works almost perfectly, and you don't need to have any coherence between the images. So this is really pretty nice. And then finally, if you have really good orbits, in the old days, we used to take the interferograms and they'd be tilted like that, and you had to remove some kind of trend or do some weird thing to it. And now there are some trends, but pretty much they're all due to atmospheric things, not so much the orbit. So orbits are really important. So like we said before, with Sentinel, they'll give you these restituted orbits right after the satellite flies over, but if you want to get the really precise orbits, you have to wait a little bit so they can do some orbit corrections. Skip all that. Yeah, I'm just gonna. So there's a file that you have in all these processing. It's sometimes called an LED file. And this contains what's called the state vector of the satellite. And it's really pretty simple. It has time, the position of the satellite in X, Y, Z coordinates, and then the velocity of the satellite in X, Y, Z. And that's given about every minute. You'd think you'd need to know it more often than a minute, but a minute is good enough. An orbit's about 100 minutes. So you need to have this file, and you see how many decimal places are here. They've got down to millimeters here. So this is a key thing in the processing, having that orbit file very accurate.
What is the reference point for the orbit?
That's a really good question. So you take the Earth, and you build a coordinate system where the center of mass of the Earth is the center of this Cartesian coordinate system. And then the X vector goes out through, 0 longitude, and the Y goes out at 90 degrees. But that whole, the Earth isn't just spinning, uniformly in time. It's got variations and it tilts and wobbles. So all those things have to be corrected while they're doing the orbits. Earth orientation parameters and center mass parameters and all that kind of stuff. So it's all done with GPS, basically. So you have all these, you have a global distribution of about 1,000 GPS stations, and they're all tracking the GPS satellites up there. Their positions are known precisely because they've been sitting there for years. And so these 1,000 positions, they're tracking the GPS satellites, providing very precise orbits for the GPS. And then every one of these SAR satellites has a GPS antenna on it that is ranging to the high satellites. There's no atmospheric problem or anything. And so it's all done with space geodesy stuff. So this is really the key. This makes our life really easy if you got good orbits. Yeah. So sometimes the orbit, that ephemeris file is given in an Earth fixed coordinate system, which is great. Sometimes it's given in a rotating coordinate system, and you have to undo the rotation. So inertial, yeah. Yeah. So then you have to know the rotation rate of the Earth and how it varies with time. think you had to code that up or something.
Yeah,
Didn't you?
it was Japanese language they lost. Only one of them. You can figure exactly.
Yeah. Yeah. I'm going to quick spell that. So, let's call that. So one of the key processing things that's really simple conceptually, it's actually pretty simple in the code, is to figure out when the satellite, you pick a point on the ground. This is our latitude, longitude topography point, just one point in our topography cell. And we have this precise orbit, and we fly the satellite over this point, and you calculate the range at that point, and you find the minimum range, and we call that, well, if it's in, well, I'll call that the range coordinate. And then the time that that happens is called the azimuth coordinate, and it's called back projection. It's a way to take every point on the ground in lat, long, height coordinates and bring them into radar coordinates. And so when you see GMTSAR running, there's a program called SAT, LLT-RA, and it's just generating this range thing over and over and over again. It takes a lot of computer time. You have to do this for every topographic point in your grid and every point on satellite track. And that mapping from range, from lat, long topography to range and azimuth isn't a smooth mapping because the topography goes up and down. It's not a nice rubber sheeting thing. It's very complicated. So that's a key element. You do this back projection, and Howard Zebker has a new approach to doing interferometry where you don't do it the way we do it. It's completely different. He takes every point in this SLC, calculates the exact distance to the closest point on the Earth, and then just basically corrects the phase for that. All those wavelengths, millions of wavelengths, corrects the phase, and then just takes two of those and cross multiplies and gets an interferometer. It's really pretty slick. But it works because the orbits are so big. So that might be the future, I don't know. Howard's pushing this really hard, so.
Yeah, because then your data is in latitude, longitude.
Yeah.
Simplify, you don't have to think about range.
So all this GMTSAR might just disappear, and we'll get these beautiful SLCs and lat long coordinates.
You've got all the matrix of what Howard's doing, but
Yeah.
you can just pick those parameters, correct the phase.
Yeah. Yeah, we should do that. There's some drawbacks to it, I think.
Well, yeah, the TEM error of 10 meters is only going to result in less than a centimeter of LOS displacement. And if you have big TEM error, your phase
Yeah.
minimal LOS.
For these really short baselines, yeah.
Well, no, 'cause I mean, it's a single.
So maybe that will happen in InSAR, I don't know. Okay, so orbits are really important, and they've gotten a lot better to make our life much easier. If there's any questions about, I really skipped through that whole thing really fast because I didn't want to waste the whole afternoon, and but you could read about it if you're interested. Do the homework problems. I have all the solutions. John DeSanta, one of the students here, did the solutions to all the problems, so I could send them to you as a spoiler. Any?
That calculus on the left.
Yeah. that document's on the web, but the solutions aren't there yet. I can put them there. If you just go to, yeah, let me get a new. Downloads, documentation, file, open and preview. How do I open and preview? Right click. I don't have a mouse. Save as. It's not, you know. There we go. Page. Yeah, so the first part of this document is more about how you do standard processing, how you do batch processing, how you do ScanSAR processing. But unfortunately, that all those techniques are changing a little bit over time. So it's not accurate all the time. As I said before, Sander had written a new document on the ScanSAR that's also here on the stack time series. And then these appendices are all back at the end here. Yeah. So yeah, you can download that and do the homework. Oh, you've got a copy. Okay, cool. Yeah. So between about now and 5:30, I guess we'll just keep working on these projects. Got help, put a sticker up.
I don't know if we're gonna have time, but if we could do like an example of maybe downloading some Sentinel frames from.
You want to do that? Yeah. Okay. We'll do the Utah. Yeah. How about that? What's that? Yeah, you can still. I mean, this is the slow way of doing it, and then later on, you can become automated and do it with the fast way. So. Maybe we should make a little document here if I do this. So you go to the Sentinel Data Hub. Just Google that. Yeah, why don't you guys follow along here? There's this open access hub. And then there's this open hub. Yeah. Okay. Okay.
You don't need an account here?
You do need an account.
Okay, I made it.
Did you make it?
At the Alaska.
This one, if you register now, you get your account instantly. So maybe we want to do that.
Yes.
Just do that. Go to the Open Data Hub. Manually, point and click. I mean, later on you can use the automated thing. And okay, so let me go back. Let me go back 2 steps. Here's the Open Access Hub. If you could go directly here to this point here, Copernicus Open Access Hub. And you know you're in the right place because a map will come up. Okay, over here, it says sign up. Oh, I could make a fake one. Oh, but then you can't get an email. So this is your usual internet thing, put your name. Maybe you guys should sign up right now.
GMTSAR. I'm gonna try to do it with a phone.
Did you sign up already? Sure. Well, then the remote people can't do it. But I want to give them a little time to sign up. No, we're going to go through that too. That's what I call an eye chart, because you know how they have all those characters? I just cannot get those dates right. And that's why the stuff that Scott has and Eric has the same thing, it automates that whole thing. But you should do it once to see what. The orbits are in a different place. Yeah, they're Google a different.
In the SLCs, there is orbit data in there.
Oh, very good. Yeah. So is everybody registered? I'm going to just sign in a minute. Is it an email that they want or username? Does anybody know my password? I'll use my usual one. Worked, see? That's the password that everybody knows. Save password, yes. Okay. Okay, so you're in here. We already did this sort of once, but it's good to go through it. I always get hung up over here. This one here, you can zoom. The other one there, you draw the little box. It takes me forever to figure these things out, you know. Oh, I need a mouse. Oops. Okay, so we're going into Canyonlands. Where is that? Up here somewhere? Right? Yeah. This one. Is that good? Going north?
Yeah, and then zooming right there.
Where these two rivers meet?
Yeah, so if you go to the south, you see those elevators.
This is what you're looking at. Okay. So we want to just zoom in on that. We're going to draw a little box. And for this is Canyonlands, Utah, somewhere. And I just drew a little tiny box because I only want the scene that goes over that one spot. I don't want to get a whole bunch of scenes. Okay, and then don't forget to click this one or it'll draw a new box when you put down. I hate these things. Okay, so I got our box. Now, we only want Sentinel-1 data. Sentinel-2 is an optical satellite. Sentinel-3 is an altimeter satellite. They're all on the same website. And then the sensing period, let's just go 1 month back. Let's start June. Let's start on June 1st and go till today. And then, oops, let me get June 1st. That's the sensing period. The ingestion period, I don't know why they even have that there. Doesn't matter. I mean, oh, I see. New data. Okay. Usually takes only about 3 to 6 hours between the time this overflight and the time the data get into the system. It's pretty neat. Pretty cool. Satellite platform. Well, there's Sentinel 1A and B, but we want both. They're basically twin satellites. You don't really care which one. Product type, SLC, sensor mode. It's really the only mode it's operating in is interferometric wide. And then this is how I do it. I do a search. Interferometric wide, IW. And it found a lot of stuff. Oh, this is perfect because there are two scenes. Your point is right in the middle of two scenes, right on the edge. Always, right?
So you don't know which. So you look at the.
This over here, you see this little box there? You go up and down. This website, all of these websites are different. I have trouble with them. So you're in a really bad area here because you're on the edge of this one here. The ascending scene is okay. Let's just deal with that. Later on, Eric can tell you how to stitch these two together to make a new one scene. I forget the name of the command. It's called, what's that? Create frame tops. And it will take two of those .safe files and make them into one .safe file. It's really cool. But let's go with this. Actually, we can just do these two scenes. So I'm going to try this descending scene right there. It's, if I click on it, I go down, it's product, relative orbit 27. So once you start working in one of these areas, you'll remember 27, and remember the other one will be some other number. Scroll up.
So you can see that there's actually that entire square is not actually covered.
Over here, there's some missing. Yeah.
So if you go and you look at that overlap one, probably gap on one where you're
It's annoying because they don't always have the frames in the same place on every cycle. They move them.
Well, the bursts are all.
The bursts are there, but the framing.
This is one burst here.
Yeah. That little thing.
Burst, right here, this little black area. This is like one burst.
So then, you click this button here, I think. Yep. There it goes. It's downloading. And as Scott said, you can only get two, unless you go to the Alaska Satellite Facility. And that one was collected on 2019 June 7th. So let's see if we can find one that matches it that's a little bit newer. (2019) July 1st. There's another matching scene. You can see because they're, oh, yeah. So let's download that one. So we got two going.
The reference and repeat frame be from slightly different orbits, but that they match has to be the same.
Exactly the same orbits, relative orbit number. So we got those downloading now. Now, what do I Google to find the orbits? I can't remember. What's the name of that, Eric? The site with the orbits? Okay. Here we go. Oh, that's just paper. This one here. Well, we're here, yeah. So you go to the Sentinel-1 precise orbits thing, and you have to remember, was it satellite A, or was it A or B? I've already forgotten. We can look in this download thing. They're both A. So sometimes one's A, one's B, you know, so we got A, good. So we click on Sentinel-1A, and then we go to the year 2019, and then we go to the month of June, and then, what did I say, June? Oh, I lost it. This is why you have to use Scott's tool, or otherwise you go blind after a while trying to figure this out, and you make mistakes. And just grab that whole thing. Yeah, that's Rob's approach, because these are tiny little files. Where's the downloads? There we go. And the file names are really, really long. June 7th at 1300 hours. So you come over here and you go 4 to 7, but you don't know if it's in that one or the 7 to 10. So you got to look in both, right? All right, so we're at June. Here it is, it's right here. See, it goes between June 6th, 2200 and June 8th, 00. Now right click and download linked file as whatever. Desktop, got it. Let's get the other one. The other one was downloads. It was July 1st at 1300. Notice these times are about the same. The satellite always comes over at the same time each pass. Same, yeah, time of day. So that's July 1st. Oops. I'm making all kinds of mistakes here. How do I get back? How do I go back to the year? Here we go. July 1st. 1300. That goes July 1st, 22. So that's, I got to go back. Oh, to June, of course. June 30th. June. There it is. Like, download link file. Got it. Okay. Now we go to this directory called InSAR. Oops, I'll make a new one. Call it Utah. New folder. Hit your terminal window. Make a directory called raw. Oops, make this bigger. Raw. TP. Dot. TP. Oh, good. We have almost no data. It's going to take like all day. So let that run overnight. This site is really slow. So let's make a topo grid while we're thinking about all this. Window. Did I close that? Ah, damn. Oh.
So there's no way here you can just put the lat long, like a point, and it will give you the frames that.
Yeah. I don't, but you, in our case, we know that it is track 27. That's the only one we want right now.
You put only that number and then you it up.
And then now that we have this, we'll just, I'm just getting back to the point I was before because I want to figure out the bounding box for the topo. I should have done that before. And if you use Scott's thing, you don't have to do any of this, but. Oh, was it 27 or what was that? Huh. Was it 27? 27, okay. When did they get all that? Okay. I see, it was up there. Let's do that. Hmm. 27. Oh yeah, product type. I forgot that. SIC. IW. There we go. That's 39.6. And this is 37.4. Minus minus 11. 7.4. Like 108.76. Oh. Oh, what am I doing here? Oh.
Well, I'm picking one, the most recent.
I think that's just when they process the data or something. I don't know.
We don't have to put that.
No.
Oh, yeah. Well, I think.
Do I just need to go down there and wait for them?
They're going to call you, right?
Yeah, no.
I know. I don't get any service either. Anyways, here's the key. And I have a cooler I'm going to bring in there later. So you can just let them in. And are they coming at 5 or 5:30? 5. Oh yeah. Go up there at 5.
That's just.
They lock the door right at 5.
Okay.
So if they come earlier, that's okay. Yeah. It's that Monk building with a big view of the ocean.
Okay, cool.
I remember that you weren't talking with the person, but at the same time. You were from Iowa or Idaho? I mean, we were talking. Yeah, I remember. Yeah, I don't remember.
Yeah. I mean,
We're gonna try that one, but we know that we should get something out.
yeah, I can see that.
It's pretty small.
Why don't you try one? I just cut it off and it's pretty solid.
Yeah. Oh, good.
Maybe just flip this here.
Yeah.
Yeah.
Yeah, try that.
I just make this little section.
Oh, we're using geometric.
Yeah, perfect. Yeah. You can open it. So just say open, start you can do the first side. So it's oh, you have to go and search and then get the data files.
Actually, challenge that their earthquake not very good. The instance on that event, their earthquake not very good. I think so.
Yeah, I mean,
it's there, but it's just kind of tough.
The other examples are that
the northwest, that's also was like a 7. I'm sorry, with Iraq.
Yeah.
You remember more or less the year? November.
Oh yeah, that was I mean, I would.
Okay.
All those are just test cases. Some of them have it. One example.
Oh, wow. That's our training plans. November 12th, 2017. Yeah, and the latitude is 34.6 north and 45.8 east. So 35 and 40.
Okay, what we can do is do the whole contact. And then
that one is a 7.
yeah. No, but I mean, so when you make an diagram,
these are ADOs, but we cannot get it. What is that mechanism? Like,
And also,
oh, look, it's supposed to be.
yeah, the water
The mechanism.
you might make,
Oh, it's 1600.
download all the down, and then there's a Sandra.
Okay.
Yeah, yeah. Yeah. So run a pair of the close to time and run. I'll see what so there's 3 times here. Oh wait, there's yeah. So in that image name, there was yeah, that's the time. Yeah, 2019. This is yeah. So going to the orbit and find orbit that's
Yes. Yeah.
Yeah.
They're already here.
Oh, no, I don't know. That's the current date for them. Not had a reason for using that.
It doesn't work. It doesn't do it.
I haven't even logged in yet. Getting the metadata, so I know where to.
So all those is
Nice. Cooking with gas.
Yeah.
You are the expert.
Oh, okay, yeah. Yeah, sending.
if you go. Yeah, if you don't want to do it back. Well, yeah. No. Hit control. Hit control.
Well, what happened was I grabbed another selection and I was trying to zoom, and what happened was I notified it.
I can see I need to be basically this way. If I keep it working. So this is a slightly different. You have to look at the cycle of the pattern. Right. You can start out here and start counting it. You can see that this is
Oh. Yeah, no, the reason mine is comment about the phase grading and stuff. So we commented out. Yeah, running into this. They have EOB 21 days. But if it's newer than 21 days, I'll just have to. I try to put it back. I mean, you can also do. There'll be a rest of the
Yeah. Yes. Yeah, I'm going to Alaska. But I still don't know.
But I haven't really figured out GitHub yet. It's a little different from this right now. You must use it all the time. Sorry, use GitHub all the time.
Here's something. What's the date?
I think it's November 12, 2017. And that's a man something. So like you read it, you see that he killed like
Oh yeah, so that's 2018. Okay. Here's one for 2017.
That's the one.
Yeah, but this is way over here.
That's by bad.
You can also so they can look at the
That's an aftershock. Oh, you can hear.
This is kind of like every month or so I go through scissors and earthquakes.
So this one is a 7 on me.
Yeah.
It's the one that I show you. The Japanese replace InSAR from December, I'm sorry, November 12, 2017. InSAR, is that correlation or?
No, that's just only.
So, is this the app that was University from Alaska? From ASF?
Yeah, that's the one I only.
So,
Vertex, yeah.
oh, this is not Vertex, I think.
Oh, good. Well, I think we're
This guy is great. Oh, it's 174, but when I restricted it, they say that Vertex is going out way too long. This is what they're using for the wall. But the thing is that I need to make sure that my lab run is there. With the I think this is my boss.
okay, so I would change this.
Correct, yeah. I think that was playing with the frame. Yeah, what's representing into that
Oh yeah.
You're restricting it from the original one, how it says no results. So I don't know if you have to make the time bigger. Maybe can we clear here? Okay, now it says oh, I will have to look at all of the text file here.
It's so I so your start end date is Sentinel. There's so many things that you need to do like
plus or minus 1 month.
plus or minus 1 month. Yeah. Also, the correlation is pretty bad with Sentinel, so it's
I don't know why this place. This is web app for self-feeding.
Oh, yeah. Or if you copy a local. Alright, and then after download. Yeah. Yeah, that one will work. Yeah, I graduated. You really want to do something.
Now actually the formats for this year average 3 hours
Yeah, but then
Sure not have.
Oh, you don't need to. You don't want to run.
What PC is coming?
You can't find your work. No, it's still in there. But it puts it in a strange place.
We don't have 3 times calculated. We have 3 times calculated. Back there? Hey, you have a particular view here, right?
Oh, yeah.
It's like, whenever you go to Erasmus, you pay for
Oh, yeah.
That's why they have a policy. They can sleep there. They don't have water.
I want to download the raw file.
SLC. So this is on the search.
Well, then in the script, I have to put this file in the which array.
So yeah, all those are just.
But then in the article script, when if I doing one of these, I think request was oh, so these are SLC. So this SLC are they created?
No, those are.
Oh, that's what I want. Oh, I'm sorry. I'm confusing it with save. I'm trying to look for save and SLCs. Pretty much the same thing.
Well, SLC here.
Okay. Okay, because I remember this extension. This doesn't mean anything. It's just the origin file, right?
That's the origin file.
Okay.
Yeah, the mission you make.
So can I use the orbits that I told you these are when you start? Or I have to download?
You'll have to download special ones for the I don't, the ones you download for GMTSAR won't have the essentials.
Okay.
That's that part where you use stock script, or you go to the website.
Yeah, one if possible to copy the Sentinel config text file.
Right, yeah, so you put these files in raw, text file.
The P2P, oh, and the elevation file.
Yeah, so yeah, and I get the P2P
and pull my ball on scotch.
Hops frame.
What?
Hops frame.
Yeah, because you have to run it, it doesn't seem like
Yeah. I looked in your, you didn't have PDF.
Right.
Maybe you're.
And then at least I don't have to pay
Those
$600 for each.
Actually, this last one I read,
I'm allowed to.
it might be something.
I suspect there's something bigger, there's some other thing in here that
Maybe not really large. No. Oh, wait. That's it. I don't know.
So it's like 34, 8, and 45.
Oh, that's it. That's the part, and then just get those.
Also, for so you would have this frame will have it, but it will be before that. But I don't know now where I can. Yeah, they're discontinuing next month. But it would work for today. I just want it now. Okay. Oh, that sucks. Yeah, I already registered, but I just
Oh, yeah, that's the problem.
no file. Okay, so it's taking me.
You just have to get two things.
I'm starting.
I never seen that one.
Yeah. Thanks.
What is that?
It's the Alaska satellite facility.
Oh,
awesome. Okay, trust you. Yeah. Government, trust me. I hope they do.
I think they have a filter. I don't think they give everybody an account.
Yeah, the scary thing is we don't have access to our work emails remotely.
Oh.
So I have to say, yeah, I'm government, but here's my Yahoo.
Oh, yeah.
It's more education of what I'm not using it for. Yeah.
Oh, yeah. I need one of those.
Yeah, shorter, but not.
There's a PowerPoint.
Yeah, I took it out. Suppose we can do the
Over here, fire. I think some people.
So what's covered in this?
Yeah, so just,
So
that'll be out, yeah. Yeah.
Getting the data back. Well, yeah, I mean,
That's the end, I was really comfortable with it.
oh, yeah. Why did you guys switch?
Because the machine in Hawaii went
Oh,
down,
that's right, yeah.
and they don't know how to bring it back up.
Oh, really?
Well, Victorian does, he's off after knows where, Europe.
Oh my gosh.
Talking about down there. I'll fix these guys.
I don't have a big one. They're gonna do a picture and all that. Yeah, it's six. It's in there. If you want, you can head out how we're back. Yeah, it's not a problem.
Which end of where you staying?
Downtown. Yeah. I direct. Oh, it's downloading. Okay, 22 minutes left. I don't think we're gonna be here 22 minutes.
You know, I found you can close it and go it back.
Yeah.
You'll start over. Yeah,
I'm happy that I did that rich press, but I'm not very happy that it's so long here.
For rich anything? Well, if you're looking at a fault that's running parallel to the satellite like that, so the more perpendicular the satellite. Wait. The other way around. If it's parallel, it's okay because you're looking in the. Yeah. So that's one way to start. It's actually good to make both. Yeah. What do you want to look at?
Like 34.9, 45.8.
What's it running? Principal. There was one pair of
but yeah, I have that.
Like 8.
Because it was this pre-operational. Yeah, so they just happened to have acquired trip map. It was a week after the radar. Just happened to acquire 1 image. And then the earthquake happened to.
You could look at the roof crest both sides.
Yeah.
That would be the ASIN. Definitely ASIN, because there's every 6 minutes. Oh, yeah.
You can download only one at a time.
I've seen some on the web, Twitter, already tweeted about it. Learning Twitter. Weird ones. I have like 40 followers.
So we just leave that computer in here, or do we have to take all this stuff out?
We can leave everything here.
Put your lecture.
150 characters. Break it up into little.
Well, what you can do is just take a screen capture.
Oh, yeah.
Put the whole lecture notes as JPEGs. Then you're not running
Oh.
40 characters. That's as many characters as
So slow. I've noticed that when I keep my laptop on the computer,
Suggest us to do before and after. Yeah, you have.
Maybe when it gets closer.
Yes, so yeah. Yes. What was the report that you showed from the I did this one, but I don't. Oh, that's what I could because I downloaded the Product Master and had some Roy types.
If there's anybody still online, we're breaking up soon, and we'll be back at 9 a.m. tomorrow morning.
Yes. Yes, I'm still online. I just want to ask what the project is about.
Okay, you can pick anything you want for a project. Are you interested in like earthquakes or volcanoes or?
Okay, so I can choose any location I want in the whole world, and then to create some InSAR, to process some InSAR data, create wrapping or unwrapping map like this.
Yeah, so I would go and get some Sentinel data, just one pair maybe of a new area where you think there's something going on, like groundwater subsidence or whatever. Yeah, that'd be great if you could do that.
Okay, sure.
You're in Australia, right?
Yes.
Okay. I don't know what's going. Oh, there was an earthquake in Australia.
Oh, really? I don't know that. Australia is quite stable, so yeah.
I know it's pretty far offshore, that earthquake. I don't think you'd see anything.
Okay.
But
I will check for that.
But maybe some groundwater issues, where they're pumping a lot of groundwater. That'd be interesting.
Sure. Okay. Thank you very much.
Yeah. Okay. Well, thanks for hanging in there. Sorry we cut in and out all the time.
Okay. See you tomorrow.
See you tomorrow. Thanks. Bye-bye.
Bye.